I hope it's fine. Everything should be good. Okay, so let's get started. Hi, Crystal Violet, what's up? Is this a tradition? Fine with that. Okay, let me just... Wait, you can't hear anything? That's not good. Maybe it's your volume, because it seems like OBS is at least picking up my stuff.
¿Y Rosemary también está contigo en Amanecida? Ah, hoy he descansado.
Hang on. Let me share this to my Discord because it's always, Oh, okay, cool. Alright, thank you. Here, let me just send this off first. Usually do this. And you know, if you want to see this Discord, you can always go right into the description. But, that should work. Okay. Alright, cool. So now, the plan is just to do what I was saying. I'm going to do these, I have this mashup of problems that I created. The first 4 are sort of kind of handpicked, and the last 11 are harder and also of random difficulty. So, should be interesting to see how it works. But, wait 1 second. Let me also get my chat open somewhere else so I can be able to read it and do stuff at the same time. Because, you know, it's kind of smart to set this stuff up beforehand, but it's not a big deal. Alright, so first, I'm just going to, first I'm going to make a thumbnail, because I'm very prepared for this. Setting up the stream as the stream is going on, not suspicious at all. It's right here. And I'll just add this. You know how it goes. Because this old thumbnail is the same one as... yes, it should have a few bitmask things. And, yeah, okay, ideally don't do spoilers. That's not, ideal. 1 second. Setting up the stream as it's going on. Okay, perfect. So let's begin with just a brief idea of what dynamic programming actually is, for the people who are kind of like unfamiliar with it. And at the same time, this can serve as review. So I'm going to go over a problem that like basically everyone uses, but the reason everyone uses is because it's a really simple and nice introductory problem. So, do you need to know basic DP? I mean, it helps to know what the concept is, but you don't necessarily need to, like, be able to apply it yet, I guess. Yeah, no spoilers. Okay, so I'm gonna go with Fibonacci because everyone knows that. So the basic idea is you have this sequence. Let's call it f of n. And it has a formula for it, which is essentially, it's a piecewise function, which means that like for certain values it behaves one way, and for other values it behaves other ways. So, please teach Yusuke mowing. Maybe later. I'll take custom requests after we get through this. So f of n is defined as, I think it's 0 if n equals 0, and then 1 if n equals 1. Or the other definition is f of n minus 1 plus f of n minus 2, the previous 2 elements. Oh, mowing mist. No, not that one, not that one. I can't do that one. Okay, now this is the problem. So if we were to write some program like just straight up uses this definition, like for example, here's what the code would look like. Oh wait. It would just be this. And we just straight up write code that uses the definition of Fibonacci. Now think about like what happens with this code. So we begin by, let's say we call f of 5. This is also kind of a well-known diagram. Let's say we call f of 5. Right now I'm just going briefly over what dynamic programming is. Like, why are we doing this? What is this useful for? Why is it so necessary? And then after that, I'll get into the problems. So f of 5, well, it relies on f of m minus 1, which means that it relies on f of 4. So this is going to call f of 4. Actually, I'm going to do f of 3 first. But because it also relies on f of m minus 2. So it will call f of 3, and it will also call f of 4. Okay, in a similar manner, we can kind of, we can just like keep on. Oh, I didn't make these problems, I just kind of gathered them around. We can keep expanding this tree. Now, f of 1 is just, f of 1 is just like, we know it. It's like known. So this isn't going to generate any more recursive calls. But this will keep going down to f of 0 and f of 1. Now, we do the same thing here. We go to f of 4. This is going to call f of 2 and f of 3. And then we can expand all of these out tediously and annoyingly and pointlessly, because that's what happens. Like, look at how big this tree is. For f of 5, we want to know 6 values, but look at how much work we're doing to do this. Right? Like, there's some of this is just pointless. And actually, look at this. This whole subtree of calling f of 3, and this is the exact same thing. So like, why are we doing it again? We just did this here. Why are we doing it again here? And if we expand out to higher values, it's going to like repeat more and more and more. Why are we doing it again? So the whole point of dynamic programming is that we don't do it again. We figure out the value of f of 3 here, and we know its answer. And then when we get to this point where we require that we need to know the value of f of 3 again, well, we already know it. So we check that we already know it, and then we cut off this whole thing here. We don't redo this because we've already done it. That's what dynamic programming is. Essentially, we store answers we've already computed and use those stored answers to prevent ourselves from wasting time by redoing a bunch of things. So in terms of implementation, how would this work? Well, say you just had like a big array. Let's call it a cache, for example. Yeah, memoization is one form of DP. I'm also going to go over the other form. Like, this is called recursive DP because it's a thing. Let's say we just had a cache which was of size, like, it would store all the numbers from 0 to n. So we call f of 5. And then we do the same thing. It relies on f of 3 and f of 4. So now we do the same thing. We rely on f of 1. F of 1 we find the answer for, so now we store that in the cache. And f of 2 we don't know the answer for, so we keep going. This goes to f of 0 and f of 0 and f of 1. Both of which we already know the answer for. And then once we do this, now we get the answer for f of 2. Alright, this is going to be introductory DP. I'm not really going over advanced concepts here. Probably not in this stream at all, because most of these problems aren't designed to be the crazy stuff. I'm not making cash. I don't even have monetization on. I'm just doing this. Right, okay. So now f of 2, we just learned. We used f of 0 and f of 1, and now we know the answer for f of 2. So let's put it in the cache. So now we've cached f of 0, we've cached f of 1, we've cached f of 2. Whatever these answers, oh yeah, cache. Okay, sure. I see. But we've cached these 3 values, and now we know the answer for f of 3 because it relies on these 2, and we know both of them. So now we've cached f of 3, and comma before space. Okay, whatever. And then, so now we have to compute f of 4. Yeah, f of 1, I'm not sure. So now we call f of 2. Now, normally f of 2 would also call f of 0 and f of 1. But first, before we do this, we check that f of 2 is in the cache, and indeed it is. So instead of recomputing f of 2, we simply use that answer that we already know, and we cut it off. So f of 2 is done in one operation instead of in 3. And then we do the same thing for f of 3. F of 3 is already in the cache, so we use that answer and we cut it off. And that's it. So what it means is every value is computed exactly once. So there's no sort of like big blowing up of this tree. Everything is done once. That's the idea. And this is called memoization. Oh, and by the way, once we do this, we know the answer for f of 4, so we can also cache 4. And then we know the answer for f of 5, so we're done. This idea is called memoization, where we memorize, like memorize, but like without the R for some reason that they decided this name was. We memorize the answers that we've come up with before, and now we know them, so we don't waste time redoing it. So instead of this exponential complexity that we would have originally had, like O of 2 to the n, we compute everything once, and like everything only relies on 2 values. So it just becomes O of n in terms of complexity. So in terms of code, this is actually very simple. Cache, let's do like, let's say we're computing f of 20. Right, and then we use -1, because no Fibonacci numbers can be -1, we use -1 to represent a number that doesn't exist yet. You can also do something like this, where you just keep a Boolean array of whether you've found the answer or not, and then you can use that as reference. But let's see. So we optimize it like this. If we already know this answer is not equal to -1, instead of doing the recursive formulation, just do this. Return cache event. I'll do the subscriber count when we start the actual problems. Okay, so now we know that the answer is going to be f of n minus 1 plus f of n minus 2. So why don't we cache that now, and then return that. Now this is going to be much faster, because again, it uses this idea of storing answers we already know. So this is memoization, and the other way to do it is the more popular, or the more like, it's more of what you would call dynamic programming. Yeah, everything's going to be available for rewatching. So I'll have the archive up on my YouTube. So the other form is dynamic programming, where instead of like doing it recursively, where we do a cache and store the previous answers, instead we kind of like, we sort of more mess with the idea of using previous answers. Let's compute first f of 0, then we do f of 1, then we do f of 2, and then we keep going in increasing order until we get to f of n. Right? Okay, why is this useful? Because like any value of f of n is only going to depend on previous values. For f of 3, we only need to know f of 2 and f of 1. So if we make it so we compute all of the previous values before we compute this one, then we're automatically going to know the answer to f of 3. And then when we get to computing f of 4, we already know the answers for f of 3 and f of 2. And then we just keep going. Right, so unlike memoization, which is recursive DP, this is sort of like iterative DP, where you would do it as a loop. And so you would literally just, like, you would literally just do it. And then you store all these answers in sort of the same kind of cache, but it's an array instead. Yeah, it's bottom up. Meanwhile, memoization is sort of top down. You start at the top, and then you like propagate down and compute the states like that. Right? So you just do it in this order. And then you say, in array format, f of n is equal to f of n minus 1 plus f of n minus 2. It's just an array. Right? So here's the other way you would do this. I'll delete memoization. And usually with arrays like this, you would just call them DP. Or actually, I'll call them F, I suppose. N equals 20. Then, actually, we wouldn't do the base cases in the loop. So first, we begin with the base cases. We know f of 0. Base cases are just values you immediately know. Like, for example, the base cases in these would be 0 and 1 because they don't rely on previous values. How much will the stream cover? Yeah, it'll be like a lot of problems, I suppose. Probably going to go on for a while. So we know f of 0, we know f of 1 equals 1. And then we just straight up like do this. That's all it is, because like that's it. This works because we guarantee that when we're computing this, we already know the previous answers. And in general, in this sort of like loop style DP, what you need to make sure is that yeah, matrix exponentiation. Sure, I'm definitely not going over that right now. But yeah, that is an extra thing you can look into. But the idea with this is that you just need to make sure, increase the font size, I suppose. You just need to make sure that when you compute a value, you already know the previous values. That's all the ordering has to satisfy. That when you compute a value, you need to know the values that it depends on. But other than that, you can do it however you want. Okay, now this is called pull DP, where this answer sort of pulls from previous answers. There's yet another way that you can do this, and this is actually the way I prefer, which is called push DP. And the way push DP works is you see that f of 2 relies on f of 1 and f of 0. But instead, you can sort of reverse these conditions. You can say that f of 0 contributes to f of 2. You can say that f of 1 contributes to f of 2 and contributes to f of 3. You can say that f of 2 contributes to f of 3 and contributes to f of 4, and so on. Personally, I find this easier to work out. It's based on preference, basically, but the way you would implement this is you still begin with the base cases, but now you would go here, and you would say f of I, actually, we'll ignore 0 because it's 0 anyway. So then f of I plus 1 plus equals f of I, because f of 1 contributes to the next value, and f of I plus 2 plus equals f of I, because it also contributes to the second next value. And then by the time we get to f of 2, we will have already processed all the things that contribute to it. So in the same, like by the same argument kind of, we know f of 2 by the time we get to it. So when we get to f of 2, we're allowed to push it out because we already know its answer. So this is called push DP. Hi Kostya, how are you doing? Are you tuning in for the later brickage that's going to happen? I do not have every Monday off. This is a specific Monday that I do have off. But usually, I probably will stream on like Wednesdays or something, because that's also a day when I'm open. It kind of just depends. That's the reason you should join the Discord, because it's always going to be inconsistent. Like, stuff is always happening that changes my schedule. So yeah, in the Discord, which is in the description, like it's like right here, You just open it right now. It's right here. You can get notifications for everything. So when things change, you can still find them. Or you can also go to the community tab on my YouTube, either way. Both of those places I'll be announcing streams. And even on this Code Forces thing, like right now, you can see this stuff. But yeah, there's probably not going to be any sort of element of consistency. I'm sorry about that. Anyway, that is my intro to DP. Took about 20 minutes, I don't know. Yeah, alright, now we get into the problems. Are y'all ready to have your minds not blown, but sown, I guess? Okay. I am recording this. YouTube will automatically upload this as an archive later. So that will be fine. Alright. You have, okay, I've already read this, but you have a given integer n. Find a number of ways to fill all 3 times n tiles with the shape described in the picture. Oh, wait, actually, first, time-old tradition that always before starting, I add my current subscriber count to my template. And I've definitely explained this before, but the ultimate goal with this is to try and get a memory limit exceeded verdict by having it take up so much memory that it crashes. I reckon it'll take about 9 million or so to do that, so maybe next week, we'll see. Alright, you have a given integer n. Find the number of ways to fill all 3 times n tiles with the shape described in the picture below. Upon filling, no empty spaces are allowed. Shapes cannot overlap. Right, okay. So, let's kind of just like think about what can we do to this. We have this grid. Let's think of it. Wait. Figure out some way to draw this. Will I mod it back when it exceeds? Maybe. I actually don't know what I'll do. Hopefully by the time I get there, Code Forces will have upgraded their systems and it'll be 512 megabytes or something, so that it won't ever be a problem. Like I'm sure with the prowess of computing power, like the standard memory limits are going to be higher or something, and then constraints will just have to be higher too, because computers are going to be stronger, I imagine. Not actually sure how much farther we can take it, but it should be pretty good at least. Okay, so we have to fill all of the tiles with the shape. This is barely visible, is it? We have to fill all of the tiles with the shape. Let's do it like this. Which means like no matter what we do, we have to put something in the top left corner. Right? So there are like 3 different ways to put something in the top left corner. We can do it like this. This is one way. We can do it like this. Or we can do it like this. Let's look at all of these cases. What happens with this problem? Right? So here, look at this. Like, this is a problem. Because when we put this down, what are we going to do about this cell? There's no way we can put something down to fill this cell. Wait, it's like... There's no way we can put something down to fill this cell because all of these are blocked by this. So automatically, we can't do this one. We're blocked from putting this L shape down. So we have 2 other ones that we can do. We can do this one. And then what happens here? Now again, look at this cell. There's only one way we can fill this cell, and it has to be with something like this. So if we put this one down, we automatically have 2, what is it? Like we automatically fill in 2 of the rows. So this is one way to do it. And the other way that's possible is this one. But again, look at this cell. Like look at the cells that are blocked off by when you do this. How does putting this down affect the state? It makes it so it's harder to put down other things. And the only way to be able to fill this cell is by doing this. So again, when we put something down, we cover the first two rows. So there are two ways to do this. We can do it like this, or we can do it like this, blue with blue. And either way, it fills in the first two rows. So the first thing is, if we have an odd number of rows, then there's no answer. And otherwise, well, okay, so the answer you can think about it mathematically, but this is a DP stream, so I'm going to solve this with dynamic programming, even though it's like kind of unintuitive. Let f of n be the answer for a grid of n rows. Yeah, it's just 2 to the n over 2. It's fine, but I'm going to do it with dynamic programming. So let f of n, actually, wait, okay. I said 2 to the n over 2. It's okay. Let me first, okay, so all I've done is Fibonacci, right? And so it's kind of like, well, how do you apply this sort of concept to other things? So there's a sort of strategy you can do to approach a dynamic programming problem. There are a few things you need to know to be able to make it work. You need to know the state. The state is what information are you carrying, like what information are you storing answers for. For example, in Fibonacci, the state is just n. That is, we're storing the answer for a, what the hell? What just happened in chat? Okay, I'm gonna trust that that mute was warranted. So this essentially, the way this works is we store the answer for a single number, and that number is the only bit of information we need. However, we could have other states, like we could have states that rely on two numbers. For example, in a grid, one possible state could be the row and the column of a cell. And so it's not able to just... I didn't see the messages, by the way. All I saw was that they were removed, so I'm not exactly sure what happened. But this is, the way this works is it's going to be two numbers. And really we can have a state be whatever we want. It can be like 12 numbers if we want. We could have, I've solved the problem before that was 6-dimensional dynamic programming. Like it relies on 6 different numbers. And this is like stupid, but it's possible. The state is the information that we need to maintain. Like, and with this, with the state, you should be able to uniquely determine the answer. So I'll kind of get into what that means later and what kind of states aren't enough information. Because like the state has to represent the whole problem. So there's also another thing. You need to know the transitions. For example, in Fibonacci, the transition would be f of n is equal to f of n minus 1 plus f of n minus 2. In certain problems, this is the first problem on the mashup. I'm doing the mashup in order. So you can also find the mashup in the description right now. Yeah, no, I'm reading chat for questions mostly. I just saw that something weird happened and I was confused. F of n is equal to f of n minus 1 plus f of n minus 2. So this defines a way to find the answer for a given value based only on previous values. This is a recurrence. And perks for spamming Kalingal and IGM chat ors will mean ban. I think that's the best. I think that's the best reward for doing that. Yeah, I can put the current problem on. Sure. Although you have to have access to the mashup, so just click that link. F of n is equal to f of n minus 1 plus f of n minus 2. So the way this works is this just defines a way to find the answer for this based on only the previous values. And this is what dynamic programming needs, because all we know are these previous values that we've computed. Right. So there's one or two more things depending on how you argue. You also need, for example, base cases usually. For example, we are given that f of 0 equals 0 and f of 1 equals 1. In most cases, this is the only way to make this happen. Like, we need base cases because otherwise, like, there's no end to the things we're computing. If we didn't have these, this definition of f of n would go into negative numbers, and it would go down to negative infinity because we never stop. We just keep relying on previous values, but these previous values, like, don't exist. Yeah, they do need base cases. Someone figure out if Mikey should get mod. I don't know yet. So this is only in context of Fibonacci. Is there anything I forgot? I guess we'll figure out later. But this is the basic overview. If you can find all this information, you can do a program with dynamic programming. If there's no like plausible state that stores enough information to find the answer, it probably isn't dynamic programming. It just depends. But you definitely, like, obviously you can't apply dynamic programming to everything. How can you understand if a problem is DP or not? That is a hard question. It's not really understanding if it's DP. It asks, like, the way to determine if you can use DP is just to check if you can use DP. Like, in terms of competitive programming, you're allowed to try a lot of different solutions and see what will let you do the answer. Yeah, part of it is experience. Part of it is other things. Yeah, overlapping subproblems is also another way to think about it. But the idea is, just think about DP, and then try and come up with this information, and see if you can apply it. And if you can't think of any plausible way to apply a dynamic programming solution to it, then it's probably not DP, and you can think of something else. It's not really necessary to try and, like, flag a problem as DP and then and only then think about it. You can just think about every problem and try to solve it like a dynamic programming problem. And if it works, then it works. And if it doesn't, then you can try other strategies. DP makes sense until they, like... Yeah, harder DP comes with kind of experience. You need to, like... There are a lot of tricks you can do with DP, and oftentimes you just need to come across them in problems to be able to understand them. It's way too many, like, things to go over. But anyway, I'm going to explicitly go over this process for this problem. The idea is, for every 2 rows, there are exactly 2 ways to tile it. For every 2 rows, there are 2 ways to tile it. So let f of n be the answer for n rows. First of all, there is one way to tile no rows. You simply don't put anything in. So the base case, I'm going to use... Actually, no. So the base case, and yes, I am drawing with a mouse, by the way, which is why the handwriting isn't perfect. The base case is f of 0 is equal to 1. Because 0 rows, we have exactly one way to do it, we just do nothing. Okay, the base case is this. And then now we need... Well, okay, so this is the state, right? The only thing that matters is the number of rows we have. We don't care about the column because we're filling in entire rows at once. So the column is irrelevant. All we care about is the rows. So the state is f of n, the base case is f of 0 equals 1. And then what happens here? Say we have 4 rows left. Well, in one, like, move, we have... Yeah, that's a really good quote. Those who don't remember the past are condemned to repeat it. In one move, we can fill in 2 rows, and we have 2 different ways to do it. So, think about what this would be in terms of f of n. The transition is, we can fill in the row one way, and then we add f of n minus 2. because we fill in the row like this, and now we're interested in the number of answers for 2 rows, because now we don't care about these rows. We've reduced the problem to having 2 fewer rows. So if we fill in one way, then we add f of n minus 2 the answer. We can also fill it in the other way, which I will label as brown. We can fill it in like this, which is also plausible. And then we fill it in the other way. And then we add another f of n minus 2. And the way you work this out is, you basically think about, when you have a problem where you're solving for n rows, what can you do? Like, what does the problem ask you to do? In this case, the problem asks you to fill in the tiles. So just think about the ways you can fill in the tiles. That's essentially the way this works. You have 2 different ways to fill in tiles. Both of them remove 2 rows from the equation, so you work with a problem with 2 fewer rows. And both of them ask for the answer of having 2 fewer rows, which is f of n minus 2. So we get the recurrence f of n is equal to, one way we can do it is to add f of n minus 2, and the other way also adds f of n minus 2. So the recurrence finally is f of n equals 2 times f of n minus 2. Oh wait, that's ugly. Where did I learn dp? I think that's a good question, actually. I think it was Yusugo training. That was my foundation for everything. Although it took me a long time to understand. Like, if you're having trouble learning DP, that's natural. It took me months to get. But at the same time, I think one of the problems was that I didn't have enough examples. So, right, okay. So, like, I mean, this is clearly optimizable, but the whole point is that we're doing this with dynamic programming. And this is it. This is the recurrence we have. Let me move this over. Alright, we have our 3 things. So let's do it. But actually, here, wait. Let's apply the age-old trick of converting this into iterative DP. Yes, this is for beginners. Let's apply the age-old trick of converting this to iterative DP, where we essentially replace the parentheses with brackets. And now we're working with arrays instead of this. This is magic, isn't it? But now, like, we just straight up have a recurrence where we can do arrays with this. So as long as, by the time we compute f of n, we know f of n minus 2, then we can find the answer for f of n. Which means it's equivalent to saying, when we compute f of n, we want to know all previous values. We want to do f of n after we do f of 0 to n minus 1. Which means let's just compute f of increasing order. So let's do it like this. Yeah, okay. That's true. With f of 1, when you have exactly 1 row, there's no way to do it, because you can't put any tiles down that make it work. So yeah, you're right. Sorry, there are 2 base cases. F of 0 equals 1, and at the same time, f of 1 is equal to 0, because there's no way to do it if you have 1. So let's do this now. How this work? C into n. F n plus 1. We need to know the numbers from 0 to n. F of 0 is equal to 1. F of 1 is equal to 0. For I is 2, I up to n. F of I is just 2 times f of I minus 2. And then we're done. Oftentimes, once we compute this recurrence and we make all this work, it's just like, it's just nice. See if it works. Hopefully it does. We get 4. Alright, we've solved the first problem. I'm going to ideally not go as slow for all of these because it's going to take a long time, but that's the idea. So yeah, procedurally, find the state, find the information you need to know, find the base cases, and find the recurrence. And oftentimes, it's a better idea to find the recurrence first, because then the base cases are just like, you need enough base cases so that you don't like recur infinitely, which means at some point you have to stop. So it helps to first know the recurrence so that you know the values that you need to stop. And in fact, even during this stream, after I figured out the recurrence, someone pointed out that I had the base case wrong and that I needed more information. So it's generally a good idea to first find the state, and then find the recurrence that operates on the state, and then find the base case that works with it. Yeah, also base cases are kind of like the easiest part, because it's just like thinking about certain values, and you can easily compute certain values. I'll take specific requests after this mashup. Okay, right, so this is it. This is all the code is. We just straight up do it. F of 0 equals 1 because with 0 rows, we have exactly one way to fill in the rows validly. Like we just straight up do nothing. And f of 1 is 0 because with one row, there's no way to do anything. There's no way to fill in these things. F of 2 equals 2. Yeah, that also works. In terms of a more intuitive base case, you can define it like this, and then f of 1 equals 0, and not worry about f of 0. Like, f of 0 kind of represents the way to do it with 0 rows, but at the same time, it's also just convenient implementation to define it as 1. Like, it's kind of the same... Actually, no, I'm not going to talk about math, but... Like, you can do whatever you want as long as in your implementation you get it right. You can mess with things. It's okay to do that, as long as it's correct. Okay. How can you come to the state? Well, that's a good question. It's kind of, at the same time, computing... Like, what is the problem asking? This problem is asking, given a grid with n rows, or given a 3 times n grid, specifically with n columns, my bad, what are the ways to tile it? So this 3 is fixed. The 3 really doesn't matter for the answer. So the only like input value is that we have n rows. So to solve a problem on n rows, what can we do? Well, we can try and reduce the number of rows, and we can make it so we have the exact same problem, only with fewer rows. With other things at the same time, you could just... Either they don't affect the answer, or they do. And if they affect the answer, then you need to store them in the state. So, as an example, yes, the input defines the state, kind of. This wasn't 40 minutes per problem. I spent like 20 minutes explaining the first thing. So, if we had, for example, more than 3 rows, like this 3 wasn't fixed. We had, for example, k rows and n columns, then we might need to define the state differently. We might need to define it as f of n and k, because now the number of columns is important. It just depends on what the answer depends on. And it's going to be hard to figure out the state. That's like the hardest part. I think with intuition and sort of relying on practice problems, and like the problems you practice, yeah, f of k n maybe. Either way. Like with sort of practice problems and previous problems and stuff like that, you can get better at identifying what you need to store. It's mostly intuition. Okay, and fun fact, there's a much simpler formula you can do than dynamic programming, because people wanted that. It's simply 2 to the n over 2. Because for every 2 rows, you have 2 ways to do it. and the rows are independent of each other. So it's just 2 times 2 times 2 and over 2 times. Right, but there's no reason to implement that. So that's another way to do it. I'm just doing it specifically with dynamic programming. Okay, anyway, that was the first problem. Let's do the next one. Does not say I solved it. I did solve it, right? Okay. Alright, now we get into more serious problems, I suppose. You have a string consisting of n lowercase Latin letters. You decide to type all substrings of the string s. Okay. A substring of s is a non-empty string x equals s of a to b, so like a contiguous group of characters. Yeah, but the keyboard is broken, and therefore you can only use k different letters. In the IGM video, I said don't stop, keep trying things. Now I say I have to stop. When did I say that? Keyboard is broken, namely you can use k Latin letters out of 26. So you're interested in the number of substrings that you can still type using the broken keyboard. Okay, n is 26, n is 2e5, k is 26. Yeah, the mouse is loud. I don't have a better way of drawing. I'm eventually getting a writing tablet, eventually, just not yet. Oh, coach mode? Okay, that makes sense. I'll just stay in coach mode then, it's not really that big a deal. Oh, that's what you meant. Okay, yeah, sure. Well, that's not you stopping, that's the program stopping, that's different. Okay. So let's formally write this out. Abacaba, is that how this works? Yeah. Do I have a PC too? No, it's just the Wonder laptop. Facecam coming at 10,000 subscribers. You guys could get me there, you know. It could happen. It's all up to you guys. Now the first step for doing this is, like, the first step of attacking this problem is, like, what can we even type? We can type any character that's valid. That is, we have it on our keyboard. But, like, at the same time, all these valid characters are kind of the same. It doesn't matter, yeah, I have my water bottle with me. It doesn't matter what the character is, what really matters is if we can type it or not. So let's reformulate the problem now. We have a bunch of characters, and let's define a character to be 1 if we can type it using the keyboard, and 0 if we can't. So for this problem where we have A, B, C, Abacaba, and we have A and B as the possible ones, then all of these characters are going to be 1s and the rest are going to be 0s. And now, asking for the number of substrings that we can always type is equivalent to asking the number of substrings where everything is a 1. Now there are many ways to do this. You can do this with math. I would prefer not to. Let's solve it a different way. In these sorts of counting problems, there's like this universal trick you should always try. You should try to fix something. That is, say, what I'm going to do here is, I came up with this kind of by intuition, but the way to fix something is say, I'm going to solve for this being the last character. This C is going to be the, yeah, I would use math for this, but it's a DP stream, so I kind of have to.
Yeah.
So I'm going to say that we're going to solve it for the number of substrings that end at this character. So the substring that ends at this character, the substrings that end at this character. And like, how do you come up with this? Well, you just kind of got to try a lot of different things. And one of the things you can possibly try to fix is a single end of the character. So if I can compute the answer for all substrings that end at this character, like the number of substrings we can type that end here, then we can sum all of those up, and everything will be perfect. There are many other things you can fix, for example. You can fix the, another thing to try is possibly the length of the substring. You can say we're going to solve for all substrings of length 2. I will take suggestions later, not right now. We're going to say we're going to solve for all substrings of length 2, and then maybe that'll work out. Who knows? It doesn't work out here. And one of the nice things to fix is the end of the string. So let's do that. Now let f of I... Actually, wait. Before I even do that. Now, when we're solving for a specific end of the string, what really matters? Well, what matters is just the position. We only care about where we are. Because we don't care about the beginning, all we care about is the ending point, and the ending point is a single point. Oh yeah, current problem link. This is, please remind me to do this, I am absolutely going to forget. By the way, this other link is for MBIT, it's our program, it's our competition, you might want to check it out. It's like, it's got stuff like, we've had DP problems in the past, so if you want to do more DP, you should check that. Okay, I can't do this, but it's prepared by myself and others, so hopefully it'll be some level of quality. If you like contests, you should check it out. Okay. Let's get back to it. I'm not... Can I pin stuff in chat? Do I have the option to do this? I don't think I can. Oh, we've definitely had DP in the past. At least 2019, maybe not 2020. I do have to plug in bit, yes. It's kind of like contractual obligation. Wait, how do I pin a message? I'll figure that out later, maybe. What do I have to do? Not sure how to... Oh, wait, like a comment? Or... Oh, do you mean like a comment on the video? Or like a live stream chat? Live stream chat, like, I'm not sure how to do that. This is all I see right now. I see put user in timeout, hide user, add mod, report, and remove. What do I have to do here? Like, I know I can do it for comments. I've done that before, but it's not here. Or is it? Not sure what you mean. Like these three dots? Who is content indeed? I'm not sure myself. Try to pin any random comment. I'm not sure how to do this. Why is it that when I'm struggling to do live stream stuff, I have more viewers than actual problems? Or like after I type it, I have this. And all it says for me is remove. No. Okay. Working with the live stream isn't DP, it's MP hard. Do I have plans to set a contest on CF? I actually have, kind of. I made this like testing round and it kind of just got ignored because it was a single blog and then like not many people checked it out, but I do have a round that I wrote. Most of the problems are kind of lame, but it exists. If you want to see it. You can find it in the gym.
Hacen alquiler, venta de autos. No, Juan Carlos, no hacemos alquiler ni venta de autos, pero puedes trabajar.
Okay, I'll Google how to pin a comment on live stream.
Es un programa también que se llama Vivo.YEGO.PE. Vivo.Pro, en el cual yo te puedo brindar el número del asesor para que tú
I can remove all other comments. Sure.
la reunión en el cual él te va a explicar todos los beneficios.
Okay. I have this open on my phone right now. We're figuring this out, I suppose. Yeah, I have more viewers than I... What? This is like Dream getting like 80,000 viewers for a blank screen.
Cocoa. ¿No les hace mal la cocoa? Ah.
How do I pin a comment on my live chat?
Pero ahí está la llave.
Oh wait, it needs 100K to do that?
¿Sabes cuál es? ¿Sabes cuál es?
Creo que es esa de ahí. Creo que es esa de ahí. No, esa de ahí, la de...
Okay. Look, it's saying online that like you need a certain number of subscribers to do it. I don't know if it's possible, like for me, because I'm not that big in the YouTube world yet, but maybe later, I don't know. Like I just don't have the option. Try popping out chat. Does this work? Do I have anything better here?
Descansa bien, ya para que más tarde te levantes con fuerza.
I am not in college. Okay. I don't know how to do this. I'm just gonna get back to the problem. That is a good plan. Yeah, I'm in high school right now. I did try pinning my own comments. Like, if I do this, it just says remove, and then that's all I have. I can't do anything with it. Okay, I kind of like have to re-explain this now since we got so off track. So you're given a string, you're given a certain set of characters you can type, you want to find out how many substrings exist where you can type all of the characters. So we define a... So we define a problem. Don't we have enough mods already? I think it's fine right now. Like, there's not much to moderate. Click on manage moderators, then remove niche chat. Yeah, I've been wanting to do that for a while, actually. Okay, so we define this to be a 1. We define it to be... Yeah, we define this to be a 1 if and only if we can type it. Can we use bit masking after converting them to 0 and 1? Well, I wouldn't say that. It's kind of like... I don't think that's possible, no. I'm 17 right now. So what I was saying was, let's fix the right endpoint of the string. So, let's say f of I is equal to the number of strings, or the number of substrings f of I. I wanted to pin comments so I could have this exist as, like, I could have the current problem pinned, and so it wouldn't be as weird to see. But let's define f of I to be the number of substrings that end at I. That is to say... Nope, that's just what it is. The number of substrings that consist of only ones that end at I. What should I make you mod for? I need job and becoming mod is big on resume. Well, I'm sorry, but you're not being hired today then. So, let's say we're solving for this character. And so the first, you can find the problem here if you want to read it. Mod you or you get the, you're getting the, I thought thought you were taking the donut anyway. So, we're here. Yeah, the chat is very distracting. I agree. So we're here. So if this character is a 1, then, if this character is a 1, then, actually, let's say it like this. If this character is a 0, then, like, no matter what, I is a 0. So there's no way we can have a string ending at I that has only 1s, because, like, we already don't have a 1 automatically. I is not 1. So, instead, now we assume f of, so, automatically, if, let's define this as array A, then if AI equals 0, f of I is equal to 0. Before we continue, can we extend this to a subsequence that it's not necessarily contiguous? Well, if it's not contiguous, then it would just be the number of characters validly, and we can either have them or we don't. So it'd be like 2 to the number of 1s, like -1 possibly. That would be the answer. It wouldn't be necessary to do DP here. But so AI equals 0 implies that f of I equals 0. Otherwise, we assume that AI equals 1 because it's the only other possibility. Then what happens? Well, first, we have the string consisting of only AI. So automatically, we have at least 1. But then also, like, what about the other substrings? Well, all the other substrings that are going to be attached to this one have to end at the previous character. Now that's cool, isn't it? Because, like, now we're just interested in what ends at the previous character. And, well, we're interested in the number of strings that have only 1 that end at the previous character so that we can extend them by 1 and include this character. But, like, by definition, that's f of I minus 1. It's the number of substrings of only 1s that end at the previous character. So the recurrence would be f of I is equal to the number of substrings we can extend, plus this character itself, because that wouldn't be included previously, so plus 1. And then the answer is, over all possible ending points, how many substrings do we have? Which is essentially saying it's the sum over all f of I. And the base case is simply for a string of length 0. For a string of length 0, we have no ways to do it. We have no substrings because there are no strings at all. So then we can define it like this. Actually, I'm going to write this in red or something. Bitmasks? Yes, I do have a plan for that. Actually, I think the next problem is bitmask. I kind of like handpicked that one. Right? State, recurrence, base case, we're done. That's it. So let's do it. We have ending K. And then we have the string. And then we're going to just define a. Okay, well, it's a very like weird kind of bitmask DP. DP on trees, I don't think we do. Maybe I can do that after the stream possibly. I'll try and find stuff like that. But let's just store, instead of like storing the number of typable characters, we can instead store an array for each character and check if that character is typable or not. That's true, an array is a degenerate case of a tree, I guess. And then we say automatically it defaults to 0. So then and then we read in a character, and now it's on the keyboard, so we define it as typable. And this subtracting a just means that we normalize it to the numbers 0, 25, instead of that's what this does. So now, what we can do is we can reformulate it. We can create this array A that's 1 if a character is typable and 0 if not. If typable si minus a, ai is equal to 1, else ai is equal to 0. And of course you can get rid of the if condition, do like ternary stuff, doesn't matter. I don't have school today, specifically. I normally do have school on Mondays. Because this was like the end of the marking period or something. Right, now let's define the function. This is the dp function. And the base case is that f of 0 is 0, which we define. Then we use this. So if ai is equal to 0, then our occurrence says that f of I is equal to 0, except we one index this, so therefore we need to add to I plus 1, not specifically I. And otherwise, f of I plus 1 is equal to, as the recurrence states, f of I plus 1. Then the answer is the sum, so let's do that too. And that'll be it. I'm really glad you can't clip this on YouTube. I'm really glad you can't make clips on YouTube, because I'm sure there would be so many of me struggling to pin a comment. It would be sad. You know, part of the nice thing about YouTube is that because I've fleshed the solution out so much, it has a really high chance of like just being right on the first go. So sometimes it's an idea to like think out a solution really hard before just blindly going at it. You can use DP instead of recursion always. Not necessarily. It depends on, like, the idea of DP is remembering previous answers. So if you have like 10 to the 18th previous answers, like for example, it depends on an array element or something, then that may not necessarily be possible. Well, it's not necessarily a session, because this whole live stream is going to be available on my YouTube channel after it's done. So even if you miss part of it, it'll still be here. Also, I intend to go through these later problems quicker. We just got very distracted here. But the idea of DP is remembering previous states. So if there's nothing to remember, for example, if every state you visit is different, there's no reason to use DP. Like, it's not going to help. That's just where it applies. Okay. Move on to the next one. Yeah, this is where the bitmask comes in. Current problem is updated. Just gonna highlight that. Okay. Berlin's shop sells n kinds of juices. Each juice has its price. Each juice includes some set of vitamins. There are 3 types of vitamins: vitamin A, vitamin B, and vitamin C. Each juice can contain 1, 2, or all 3 types. Future 1v1 lockout with second thread. That is a possibility. Kind of depends on things. I do see that as a possibility. It could happen in the future. Yeah, collaborations are possible too. There are also a lot of other channels that are starting up that are doing tutorials. For example, this one guy, Algorithms Conquered, is one that I've looked at before. So you can check him out. There are also other ones. But yeah, I'm sure collaborations are possible in the future. We'll just have to set things up. Is knapsack DP? Yes, it is a form of DP. Is FFT DP? I don't know FFT, but probably not. I don't think it is.
te van a dar incluso un número para que separes tus siglas.
Right, so each juice can contain 1, 2, or all 3 types. We need to get juices so that we can have all 3 vitamins.
Saben, si es que están aquí en Lima, igual, en todos lados, tiene que tener ese
Is greedy DP? Generally not. Sometimes, generally not. So what is the minimum total price so that you can get all 3 vitamins? Alright, now this one is kind of messier. Because the state isn't so simple now.
Entonces, ¿qué es lo que te podría, Daniel?
Let's say we have some function f of x. Wait, let me scroll up. Let's say we have some function f of x. Actually, I'm just going to say this is problem C. Let's say we have some function f of x, where x is the state that we're trying to find the answer for. Is dp. Yeah. No, it's not. But like, what is x? Well, what we want to know is what's the cost for obtaining all 3 vitamins, right? And these vitamins have no relation to each other. So the way it works is, like, what can we do here? In some sort of state, we need to have it so we have information on. Contest is restricted? Yeah, to open this problem, first you have to click the first link so that you can be invited, and then you can open the specific problem. I'll put that there.
Cuando el tío llegó te estaba haciendo así.
En Diego están igual las mismas promociones de siempre. Bueno, tienes una semana completa.
No, bueno, yo por el momento no. En Diego están igual las mismas promociones de siempre. Bueno, tienes una semana completa para realizar los viajes, todos los viajes posibles.
So we need to store if we have the vitamins or not. This difficulty is 1200. So, in a state, we need to know, do we have the A vitamin? Do we have the B vitamin? And do we have the C vitamin? And specifically, we can store it like this. This is a 0 if we don't have it, or a 1 if we do. This is a 0 if we don't have it, or a 1 if we do. This is a 0 if we don't have it, and a 1 if we do. So there are 2 ways we can represent this. We can do it like this. We can make it 3 variables. And we say that this represents if we have an A or not, this represents if we have a B or not, this represents if we have a C or not. And that's like one way to do it. But there are other ways to do it too. Instead of doing that, we can compress all of these 3 into a single number. Because notice, this is either 0 and 1. This is also either, I'm doing problem C. This is also either 0 or 1, and this is also either 0 or 1. This is binary. Isn't that cool? We're interested in the binary state of whether we have an A or not, whether we have a B or not, and whether we have a C or not. But like, just think about computers. Like, computers do things in binary. We use numbers in binary. So why don't we make this whole thing just a single binary number? Let's have 3 digits. The first digit is A, the second digit is B, the third digit is C. This first digit represents do we have an A or not. This second digit represents do we have a B or not, and this third digit represents do we have a C or not. So A has the value of 2 to the squared, which is 4. B has the value of 2 to the 1th, which is 2, and C has the value of 2 to the 0th, which is 1. We're doing problem C. I'm gonna like do this now. I'm gonna write the thing at the top. And we compress this binary sequence into a single number that represents all of them at once. This is called a bit mask. It's a mask of bits compressed into a single number that represents the state we want. And this is more generally known as bit mask DP. We ask, we have a state f of mask that basically says, what is the minimum cost to have it so we've satisfied everything that the mask says we have? So for example, if the mask is 1, 0, 1, which is equal to 5, then we have to have satisfied that we have an A and we have a C.
¿Cómo trabajas con Y? Muy fácil, Richard, muy fácil.
Why is it called rolling? I don't think you can super chat. I don't have...
Richard,
I'm not a
¿de qué
partner
ciudad
yet.
eres?
Actually, I haven't even applied yet. I probably should do that at some point. But I don't have any sort of setup for that. So f of mask represents lowest cost to satisfy the mask.
No puedo escribir. Richard, tienes que escribirnos, ¿sí?
We can also introduce another state. This is sort of an implementation thing, however you want.
Richard, tienes que escribirnos, ¿sí?
And mask, which is defined to be the lowest cost.
Sí, ingresa al perfil de Llego en Vivo.
Lowest cost to satisfy the mask, where you've only used
Envíame un mensaje.
the first n strings.
Porque te he intentado.
This is generally how DP would be done.
Gracias, Diego.
Because you're going through the strings in order, you can actually abstract out this part and just kind of get rid of it. It'll be implicit, but this is the explicit definition of how to do this. It's the lowest cost to satisfy the mask using the first n string. Oh, where did these numbers come from? This is just how binary works. The first thing takes the position of 1. The second thing takes the position of 2. The third thing takes the position of 4, etc. Like, it's just a binary number. That's all we're doing here. We're converting these zeros and ones into a single binary number. And it's convenient because computers work in binary. Yeah, it's also representing kind of a set of objects, and then the bitwise operations do some cool things. But let's go with this. So f of n mask is the lowest cost using the first n strings. Alright, how do we do this sort of recurrence? This is where I prefer to use push DP. So I'm going to kind of describe how to use push DP right now. Yeah, 3 variable truth table, sure. So what does f of I mask contribute to? So the transition for f of I mask would be considering the I plus 1th string. And what we can do is, we can represent these strings also as a bit mask. We represent the string as a separate bit mask, which asks, do we have an A in this string? Do we have a B in this string? And do we have a C in this string? And we do it the same way. This is 2 to the 2, this is 2 to the 1, this is 2 to the 0. And then we'll call this mask M or something. So we have a mask for the state, and we have a separate mask for the string. And somehow we have to combine them. So the transition is, either we don't take string I plus 1, in which case we just still have f of I plus 1 mask, because we've considered the first I plus 1 strings, and we just don't use it this time, so that's fine. Or we do use it, in which case we have to consider what happens. So this is f of I plus 1, because we now consider the I plus 1 strings. But what happens here? Well, this is where the truth table comes in. So this is... You can sort of bash out the way to do this transition like this. We can say we had before we might have had it before, in which case we don't care about whether we have it here. Or we do have it here, in which case we don't care about whether we had it before. Right? So there are 4 cases. Either we had it in both of them, we had it before but not here, we had it here but not before, or we have it in neither. And well, this is just asking, like, if we have it in at least one of them, we have it no matter what. So this is bitwise OR.
Yeah. Ahí te he
you're going to
solicitado
bitwise
dos
or the
cositas,
masks
sí,
together.
para poder iniciar con la afiliación
Because if you
de
have the
Richard.
bit in at least one of them, then you're going to have it afterwards. So it's mask, logical OR, M.
Hola, M.
And the cost for this is the cost of taking string I plus 1. So you would have to consider f of I mask plus the cost for that one. The base case is simply we have 0 strings, and obviously we can't have anything satisfied, so it's 0. Because we don't have any costs either. So now let's do that. This binary number is just a number between 0 and 7, so we can represent it in an array of size 8. First we need number n, and then we can make this array of size n plus 1, and 8. Then we can do this by checking.
¿Cómo funciona? Pues muy fácil. Si es que has tenido
So we want to make it so if we can't get to a state, then like we want to make it so we're never incentivized to use that state. One way to do this is just to initialize everything to infinity, because that's the highest possible cost we can have, and therefore we'll never want to use it. So let's define infinity to be some huge number like 10 to the 17th, which we'll never get to in the cost because the costs are just 10 to the 5th. Then f of I and j is simply infinity. This also gives us a convenient way to check if we can't have it at all, because if we never reach the state, if we never reach any state, then we're like totally fine. So we also define the answer to be infinity, and then we say cost string s. So now
no sabría decirle, señorita, porque a mí el punto me sale acá, yo llevo exactamente donde me aparece el punto. Y el pata me dice,
yeah, if you watch it later and leave a comment, I'll try to answer.
Y me dice, o sea, nosotros estamos parados
Int
allá adelante
string mask equals 0.
Pero así me lo dice feo, entonces pendejo. Ya, y yo agarro y ya, pero dije, no, encima que estaban tomados. Le dije,
so for int
sí, pues, agarro y le digo, amigo, le digo, solamente llevo exactamente
like this is the position in the mask. I'm gonna stick with this notation of representing a C is the first digit, B is the second, A is the third. So this has the power of 2 to the 0, power of 2 to the 1, power of 2 to the 2. So the corresponding character is this minus the position. So in the first position, this will be a C, second will be a B, third will be an A.
Por si acaso su monto se ha modificado porque hay un tiempo de espera que ya se pasó.
Then we just go through the string and see if we have it.
Yo no te voy a pagar más, me dice. Y yo le digo, señorita, yo no te digo que me pague más. Solamente le digo que me pague lo que le va a salir en la aplicación.
Then if we have it,
y el pata se mete. Sí, pero lo que sale
string mask plus equals
tú no ibas a venir. El pata se mete, ¿no?
1 left shifted by pause, which is the same as saying 2 to the position.
Amigo, yo no soy tu papi, ya, yo no soy tu papi, ya, y yo llego al punto que tú no
Okay.
estás en el punto, no hagas revisión de tu aplicativo, yo tampoco, no es mi culpa.
Is it possible to do live subtitles?
Dice, ya, te voy a pagar,
I could try that.
Ya, y como yo lo vi que estaba así, ¿no?
I'm not sure if that's
que me paga adelantado.
possible.
Agarré, le dije, mira, ya, primero, me yapea primero, señorita. No, porque después yo voy a llegar allá y no me van a querer pagar, pues. Están así de espesos. Le digo, señorita, me yapea primero. No, yo te voy a yapear ya cuando llegue. Señorita, no, le digo, me yapea primero porque...
Wait, what is
así
this?
como están
Your
ustedes,
video doesn't require closed captions.
para evitar problemas.
It should be like
No, que yo como te voy a pagar,
automatic.
dice, para cómo te voy a pagar primero, que tú tienes que avanzar, tienes que dejarnos allá, ¿no? Digo, amigo, Leo, me va a pagar, si no, no tengo ningún problema, se
If
baja
it
y yo
doesn't,
pagaré
I
el
guess it'll
servicio.
have them after.
No, que yo te voy a pie,
Wait, can you? Are you able to
y el
enable
pata me
them?
yapea.
I guess you
Ya
can.
me
It's kind of
yapea el
annoying.
dinero. Me yapea y ahí nomás la otra chica abre la boca y yo también estaba pensando, ¿lo llevo o no lo llevo? Mejor creo que no, dije no. Y ahí nomás la otra chica cuando me yapea, el pata me dice, ya está yapeado, ya
Yeah, I
se
guess it's not
avanza,
possible
amigo.
live. Sorry about
Así
that.
avanza. De una mala
We'll
forma,
have to
¿no?
figure that
Y
out later.
ya listo, amigo, para evitar problemas, entonces dice, ya listo, amigo, voy a avanzar. Pero un momento. Y ahí nomás la chica le dijo, ya, ahora sí, cuando lleguemos, le pones
I'm
calificación
not sure how to do
mala.
that.
Ya. ¿Para qué dijo eso? Dije, sí, entonces ya, listo, tío, no voy a ir, te lo voy a
Yeah,
cancelar.
okay. Let me finish this off.
Y lo bajé a todito. No, pero ¿cómo me vas a bajar todo?
So for a certain value of I, we just like iterate through all the possible values in masks, which is 0 to 7, and then we find what it pushes to.
Las bajé toditas.
So
Si no me va a calificar mal, pues.
Claro.
Y encima que están así de espesos, dije, no, está loco, ahí nomás. Los bajé a todos, a los cuatro.
the first case is that we take nothing, and therefore we just do this. So fi plus 1 mask, it's just the same thing, equals min f of I plus 1 mask, f of I mask. That's the first case. And the second case is we do the same thing, but we do take it. So f of I plus 1 mask, bitwise ORed with string mask, equals min plus 1 mask, bitwise OR string mask, plus the cost of taking the string, which is cost.
Lo pongo iniciar y todo el viaje, ¿ya? Y la señora me dice, me dejas en el lado de Benavides nada más porque no vas a poder entrar.
And then the answer is any possible way to.
Lo veo y le digo, señora, un favor, en todo caso, cámbiale su punto de llegada. No,
the answer is the minimum cost having considered all of the strings of having the full mask of A, B, and C. So the answer is, redefine it here, f of n and 7, because 7 is the number that represents having all of the bits enabled. If the answer is infinity, then we never reached it, and therefore we want to print -1. And that's how this works. This is bitmask DP. In a sense. What do I do?
Su punto de llegada, nada más. Es cambiarle y ya. No, yo no lo voy a cambiar, mis.
No matching.
Ya, como estaba como el otro pata que había renegado.
F of I mask.
No le voy a hacer servicio. Y ya. Encima que le estaban cobrando baratazo, ¿ah? Ese servicio estaba baratazo. Yo estaba yendo porque a mí me recompensa mis 8.50 que me dan por viaje. Estaban cobrando desde Surquío hasta San Marcos, nice. 14 soles.
Cool. Oh, because I never. Right. We want the base case, setting this to 0. As we define here.
Ya le digo, señor, no lo voy a llevar. Agarré y la bajé también. Señora, ya.
15.
Su hijo será.
This should be -1. We have no answer. Should be 13. Should be 250. It should be 16. Okay, by the way, in the time that I have for the stream, I don't expect to get through all of these. That's not the point. The point is that, like, we, the point is that we just, I don't know, I'm trying to be elaborate here and trying to explain everything, and yeah, the point is not speed, that's what I'm saying. Kind of lost my train of thought multiple times. We do get the problem. Okay, yeah, there's no reason to spam a question 6 times. I will try and read all of the chat, and if I don't, you don't have to, like, keep saying it. But, practice div 2s probably, I'm not sure. That's kind of the way to go.
Los reportes antes a que
But yeah, don't spam. That's just annoying. The timeout will only last 5 minutes, so we'll be able to talk more later.
eso, entonces no te van a reportar.
So this is just D. I don't even have to change the link every time. It's just problem D. Yeah, let me read the rest of the chat. I may have missed things. From where can I practice number theory? I think you can. That should be a tag. Go to problem set and then add tag and then number theory. And here you go. You can also pick difficulties if you want, like 2400 to 3500, which I'm not going to do, but you can do whatever you want. Coforces is pretty nice. These are all 1200s. The way this distribution works is the first is 1000, the next 3 are 1200, and then the rest are randomly distributed between 1400 and 2000. So some of these are possibly quite hard. Okay. Your friend Mishka and you attend a calculus lecture. Scared of saying names. Lecture. There's so many ways to mispronounce something. Lecture lasts n minutes. He tells AI theorems during the ith minute. It's really interesting in calculus, but it's hard to stay awake. You're given a rate T of Mishka's behavior. Mishka is asleep during the ith minute of the lecture, then Ti will be equal to 0, otherwise it will be equal to 1. Mishka is awake, he writes down all the theorems he's being told, otherwise he writes them. You can keep him awake for k minutes straight, but you can only use it once. You can start using it at any valid minute that will work, sure. Your task is to calculate the maximum number of theorems he'll be able to write down if you use your technique only once. So wake him up. Watch your competitive programming journey video. I mean, you could take the same route. It's not necessarily necessary. There are a lot of ways to get good, but I'm not sure. I think just a general good rule of thumb is practice whatever you want to be good at. So if you want to be like 12,000 rating on Codeforces, you can do a lot of Codeforces problems. Because that will tell you exactly what you have to be able to do to get 12,000 rating on Codeforces. Okay, why is this DP? That's a good question. Well, you can think of it like this. Practice juggling later. I'm doing that today. I said it. I'm doing it today. I'm doing it today. I hope. I hope. Right. Okay. So here's the idea. Let's think about this problem like this. 1, 3, 5. 2, 5, 4. Now this is DP like a certain sense of the word. It's not well, actually no, it is DP for sure. So this is 1, 1, 0, 1, 0, 0. And the way this works is you want to pick a range, and then automatically you're going to get all the numbers in this range. But at the same time, you're also going to get all the numbers in this range where you have a 1, but not the numbers where you have a 0. Right. So let's do it like this. Let's say we pick an arbitrary range. Then what we're interested in is 3 things. The sum without modifying the numbers of this, the sum without modifying the numbers of this, and the sum of all of the numbers in this. Okay, now there's a cool way to do this and a not cool way to do this. I'm probably finding the not cool. So here's the idea. The idea does indeed exist. Right. So what we're interested in is the normal sum of this. So let's break this into 3 parts, right? We want the unaffected sum of this prefix of the array. We want the unaffected sum of this suffix of the array. And we want the total sum of this. So in terms of dynamic programming, it's still building off of previous answers. Let P of I
¿Por dónde?
be the unaffected sum of the
Lo voy a llevar
prefix.
acá en la victoria, lo voy a llevar.
Cualquier cosa grita, ¿sí?
Vamos a arriesgar, ¿no?
Cualquier
Tengo acá
cosa
mi fierro
grita,
para... Ay, me reviento su cabeza.
So,
cualquier cosa grita.
any prefix will consist of two
Acá tengo
parts.
mi fierro,
You can think of it
tengo mi
like this.
desarmador.
It's the last element and everything else.
Defensa propia.
Y ya, pues,
So this red part is the range corresponding to P of I, and this orange part conveniently corresponds to P of I minus 1, since it's everything but the element you just took, which is the same as the previous prefix. So P of I is equal to A of I. Whatever A of I may be, this could be 0 if the value is 0, or something greater than 0 otherwise, plus P of I minus 1.
¿Quién quiere ingresar? Vamos a ver un ratito.
This is in some sense dynamic programming. And we can do the exact same thing for the suffix. S of I is the unaffected sum of the suffix. Actually, let's say it's the suffix of the last I characters, because that's kind of convenient. Actually, is it? No, it's not. Let's say it's the sum, unaffected sum of
Richard, ¿ya está
the
registrado
suffix
con nosotros?
from I
¿Ya?
El
to
lunes,
N.
sí, sin falta, ya, porque el lunes te paga tu socio, ¿verdad? O bueno, el lunes cierra lo que es el bono.
Y el martes es más efectivo.
Ya, entonces
And
apenas cierra el bono, creo
then
que
we're
es
just kind of
el
interested in
máximo a las
that.
9 de la mañana
And then
que
the formula is
aparece el
basically the same.
activo.
We draw the same diagram. This is the part we include. This is everything else.
Para
So this is
ya
S of
realizar
I,
lo que
and this
el
is S of
cambio
I
de tu
plus 1.
celular, todo lo que es borrar datos y cachet, ¿ya? Y seleccionar Diego como socio de...
So S of I is equal to A of I plus
Ustedes están
S
poniendo
of I plus
de
1.
servicio para el bono.
Okay, no,
Es depende, por ejemplo,
that's these two parts.
hay
What about the
ocasiones,
middle part?
te
Isn't that
digo
fun?
como algo que me pasó a mí, un conductor
Well, the idea is-
estaba en, si no me equivoco, en
This is a thing. Why are you spamming dots? Is this Morse code?
I
can't read Morse code.
Para seleccionar. Y me dice, no sé si con ustedes van a cambiar, ya que nosotros no estamos
Is
tan
someone
seguros
fluent
porque
enough in Morse
no
code to
son
understand this, or is it just nothing?
de Django, ¿sí? Yo le digo, bueno, señor, hay que aprobar.
It's just nothing, then
No
that's annoying,
aprobando, ya que igual, si es que te sale nuevamente por selección, puedes
Ah.
volver a tu socio antiguo normal.
Yeah,
Y me-
I guess you can mute. I don't
bueno,
see the point of
con la
that.
sorpresa de
Mashup will be
que
active?
sí,
Yeah.
de que prácticamente
Everything,
lo
like,
cambiaron
this
a
whole
uno
stream,
de los
everything is going to be available afterwards. So,
Ok, porque yo no estoy con selección.
you can find the problem. First, click this link, and then you can click this specifically.
Por lo menos entre viernes en la noche
Everything will be in the
y
description.
ayer. No, fíjate,
But yeah,
no-
everything, the mashup, the video, all of it's going to be
no me
afterwards.
pagaron con tarjeta,
It's like
nadie.
it's gonna be available
Entonces,
afterwards.
Acumulé 50 soles que tengo pendiente
Okay.
con ellos y tengo 580 de bono.
Now
Entonces,
is a cool
aplicativo
thing
me lo bloquearon
called
porque
prefix sums.
no
We're interested
recarga,
in
pero
the sum
ellos
of,
fin de
not the
semana no
unaffected
se les
sum,
puede
but the sum of
recargar.
all of the
Ellos
array
están de
elements.
recargarle, pero yo tengo
So let's do it
que
like
trabajar
this.
mañana. O sea, tengo
It's-
el Django bloqueado hoy.
We let prefix of I
No, yo quiero transferir, pero
be the sum of the first I elements,
no, porque ellos trabajan en mañana.
not the unaffected sum, but the sum of the first I elements
Aquí
specifically.
en Diego, bueno, nosotros sí trabajamos lo que es soporte mismo, trabajamos lo que son las
Then,
24 horas.
It's the same recurrence as P of I.
Nosotros aquí
I'll do it in
trabajamos hasta las 7 de la noche.
green. Prefix, sound like my
Ok,
math
también
teacher.
yo trabajo
Prefix
de
of
lunes a
I
viernes,
is
ya
equal to
saben que
AI
se le bloquea en el Django, tiene
plus
que esperar
prefix of
hasta
I
el
minus
lunes.
1.
Entiendo.
Entonces eso, ellos trabajan bien
And the way
porque
this
yo tengo
works
contrato
is,
con ellos, el pago todo chévere. Yo no
what we
tengo
want to do is we want to
restricción, porque
use
ellos
this
no se ponen
to
a hacer
get the
30
sum of
carreras para que me
anything.
envíen uno, no.
Get the
Yo
sum of any range.
semanal hago mis
So let's
120
consider some range
carreras,
we
mis
have in the
112
array.
carreras, y eso
But we
lo
want to
tengo porque
represent
me
it
dan
as
ellos de
sort of
bono,
this
pues.
prefix thing.
Por
So
eso
let's
que te
consider the
preguntaba,
whole
porque hay otros
prefix
ya
that
nos están
ends at the end of this
implementando
range.
que tú tienes que poner la cantidad de servicio que vas a hacer en la semana. Si no lo haces, no te dan el
Okay, but
bono.
like, look, man, we got this like gap here,
Te puedo dar una
right?
noticia. hay un
What we're interested in is this.
que es doble,
And we have, all we know is this.
bono, ¿no? En el cual
So what if we
igual
just
te voy a
like,
mandar lo
we
que
do
es
this,
el
but we
link
take out this gap.
ya para que ingreses a un grupo
And then we're just left with the thing we care
donde
about,
yo llego,
right? So this gap on this range L and R, this gap is
doble bono,
the prefix of L minus 1 elements.
tienen el bono por selección,
And then this
o
gap
el
is the
otro
prefix
bono,
of R.
¿sí? Es muy interesante.
So to get the sum on LR, we just take the whole thing and then subtract out the stuff we don't want. So it's prefix of R minus the prefix. I'm capitalizing L so it doesn't also look like a 1.
Porque al marcar,
Minus the prefix of L minus 1. And that's how you would get the sum on a specific range. This is more commonly known as prefix sums, but it's like, it's a form of DP, so it still counts, I would suppose. I think that's why it was tagged that. So now let's do this. Let's just like, this is going to be tedious, and there are smoother ways to do this, but I'm doing this explicitly because it's like, just nice.
Pero está muy interesante de verdad, en el cual a los conductores
So then,
les puede interesar demasiado.
we use AI to represent the first array, BI to represent the second array.
Porque el bono por selección está 800 soles por 95 viajes. Le conviene.
And we can think about it like this. So, we'll just define it explicitly. So the base case here would be that, well, there is no P of -1, so you have to define P of 0 explicitly, and P of 0 is just A of 0, so we can think of it like that. P of 0 is equal to A of 0 times B of 0. This is convenient because if it's a 0, we don't want to count it, and if it's a 1, we do want to count it. So if we just multiply, it's going to work out. Then we can do the recurrence.
El bono por escala, por escala también es de 800 soles.
P of I is equal to A of I times B of I plus P of I minus 1.
Haces la misma cantidad.
Do the same thing for suffix.
Por 95 viajes.
I'm going in order, yeah.
Y es como que te puede convenir, sí, pero también si es que te toca algo lo de 650, está lo del
But the
doble
general
bono,
idea here is that once we're here,
Tío Gonzalo, bueno, el tío Diego, está dando mucho más información, también nos está capacitando mucho más sobre eso.
the way this will work is,
Que nos dijo que es como que tipo
I'm not sure how that would apply. It's like a fixed range subarray.
Lo que se va a hacer es muy interesante. Y ahí te voy a mandar el link, te voy a mandar
We can do the same thing, except for computing prefix sums, I usually have a specific trick where I, instead of doing the array explicitly, I store a variable that represents this, and then it's not a recurrence anymore, it's sort of like you just maintain this variable that represents the suffix as you go along. I'm not going for 8 hours now. R plus equals AI times BI, and you can do it like this. And that makes it so you don't have some sort of edge case or anything. And then we can do the prefix sums.
Ese link lo vas a copiar y lo vas a pegar en cualquier WhatsApp, ya sea de tu hermano, o de ti mismo, sí, en el WhatsApp para que puedas hacerle clic y puedas ingresar al grupo.
Isn't this font size enough? I can't zoom in that much farther. Like, it just kind of gets awkward.
¿Alguna otra consultita más, Richard, que nosotros te podamos ayudar? Mira, por ejemplo,
Is it the quality? You can also improve the quality of the video.
Ahorita tiene muchas buenas mañas, como se dice, o buenas tácticas trabajando con el aplicativo, en el cual él también te puede aconsejar mucho.
Yeah, but the way this would work would be, I want to find the best. So let's fix the start point of the interval we're using. I plus k minus 1 plus an n, because that's the end of the interval. And then now we say we're going to do this. On this whole array, we take this interval. This is I. The end of this is I plus k minus 1. Which means that this interval is the suffix I plus k. And this interval is the suffix I minus 1, or the prefix of I minus 1.
Un bendecido día, Armando, que tengas un bendecido domingo.
So, current equals 0. If I is greater than 0, cur plus equals the p-value of I minus 1. If I plus k is less than n, we do the same thing. I plus k. And the way I do this is...
Así es, apenas te figura el bono en tu aplicativo, ya nos pasa igual, te conectas, nosotros estamos igual. De lunes a domingo estamos desde las 6 de la mañana hasta las 10 de la noche. Haces el proceso de cambio de borrar datos y cachet y todo eso y ya estás trabajando con eso.
Just simply this. We consider the prefix of r. If necessary, we subtract out the previous one. And now we consider it as the answer.
Sí, al momento de borrar datos y cachet no significa de que el socio desaparece.
ASMR. All I'm doing is typing. I guess that works though.
Al momento de hacer clic en tu perfil y hacer clic en tu nombre va a figurar los socios.
Does this exist? It does indeed.
Al menos que yo toque amigo y pase amigo.
Selecciones de nuevo, sí.
Yeah. So we just compute these three things and then combine. I said this wouldn't be smooth and it's not, but it's a way to force it to be dynamic programming. That's kind of what I'm trying to do here.
Nos tienes que contactar para poderte dar.
Okay, we're on to E. It looks like this has fewer solves than normal. So that sounds fun. Let's do this. There are n people and k keys in a straight line. Every person wants to get to the office, which is located on the line as well. To do that, he needs to reach some point with the key, take the key, and then go to the office. What is the shortest time I've finished this code contest? That is a good question. Yeah, you can also do prefix sums on 0, that's true.
Okay, gracias.
Officially, I think it was 40 minutes or something in some div 3. Don't exactly remember. So then you need to reach a point with a key, take the key, and then go to the office. In order to determine the minimum people needed for n keys.
No puedo hacer nada. Dale, pues.
Igual que tengas buenas carreras, buen domingo.
So, let's think about this.
Chao, pues.
Chao, Richard.
You have a bunch of people. Ideally, I will try and go a bit faster through these. You have a bunch of people. Each person is located on some point. Let's think of it like this. And you have a bunch of keys. Keys are going to be also somewhere. Yeah, William Lin is pretty fast, I would agree. And the way this is going to work is every person is going to take a key. Oh, and there's also some office somewhere, I suppose, is how this works. And every person is going to take a path that first goes to a key and then goes from that key to the office. Oh yeah, that div 4, it took me 37 minutes. I guess that would be it. Although I didn't... never mind. When you read a problem and don't get an idea, try to get more ideas. If you don't get an idea instantly, that's normal. Generally, hard problems take a while to even think of anything. But then, as you think more and more about it, stuff will become more clear. For example, you can find some observations or things. It is a possibility.
En los olivos hay alta demanda también.
Yeah, he's very fast, I would agree. I took a while on Kickstart G because I am bad. Well, problem C was like a pain.
600, Michelle, tú estás acá en
Okay,
Lima.
so the basic idea for this problem is, and I only came up with this so quickly because I've seen it before, but like you don't,
650. Igual
the
como,
trick here is you don't
como
want
le
any
estaba
crossed
comentando a
paths.
Richard,
So consider some, I'm gonna move this down.
están como que dando como un tipo
Consider
de
something
modelo,
like
que es
this.
el doble bono, en donde está muy interesante ese.
Well, first of all, you're going to assign every person to a key. So we can think of it like this, where we just kind of draw out this assignment.
¿Cómo se llama? El link. Escríbeme el
Right?
interno y
And then
te
this
mando el
person will go over here, for example. What to do if you're stuck at newbie and coforces? Well, that depends. How effective is your practicing? If it's not working, you probably want to try something else, I suppose. You would want to see what's working, what isn't, and I'm not sure. Improving is just kind of like a random thing. You just gotta like throw yourself at problems and be better at thinking. And the only way to do that is to have the experience. I don't think it has a greedy solution. There's no guarantee that the greeting would. Oh, come on, you've been newbie for like 3 weeks. There's no way that the greedy solution would be guaranteed to work. Wait, I'm gonna draw this here. So now let's consider this. These paths are crossed. So like, the idea is that we don't want to cross these. Because consider this. Consider it like this. Let me figure out some way to illustrate this that isn't true. If you have a greedy solution, it is possible with greedy, but I don't think it works. That's the thing. So you have an assignment like this. But like, I claim that this green assignment is always going to be better. That if you have two paths where this is less than this and this is less than this, but this is assigned to something later than this, then it's not optimal. And this is just like well known. I mean, the way to prove this could be something like this, where it could possibly you could possibly do out the casework. Like you can do out this sort of casework and realize that in every possible case, the green assignment is going to be better. But this is just true. Like this is an idea that is always going to 7 streams for a single contest. What the? Yeah, basically this green thing is going to be better. Let me try and figure out some way, like non-annoying way to prove this, because they're like if you do all the cases where like for example the blue points can be between the reds or they can be on one side or the other side, there are a lot of cases that you can all work out and they're all going to say the same thing, that this green path, this green assignment, where if you don't cross the paths is going to be better. But that's the idea, which basically means that the assignments of the keys you do are going to be in increasing order. So you have the numbers 1, 2, 3, and 4, and you have 5 possible slots. Then it's going to be something like this. Like for example, this would be the assignment. But you can't cross them, so you wouldn't have something like this. Every like assignment number will be less than the next one. Why am I saying this so elaborately? Because what it means is you can automatically assume when you've assigned the third person that you've already assigned everything before that third person. And we're trying to do DP here, right? We're trying to get some sort of reasonable state that represents everything we need to know for the problem. And I've just shown that the only thing we need to know for the problem is the last person we assigned.
Ya Edgar, ya está listo.
So that's cool, right? And also the position at where we... Like the position we're at and the last person we assigned. So if we were to write some DP based off this, it would be dp of position, and last person. That would be it. That's the only information we need to know. Because with this information, we can uniquely determine like the answer and the problem we're solving and everything. But you see how this wouldn't work if we can do them in any order, because it's not enough to just say that we put down 3 last, because now, like, what if we put down a 1 or 2 afterwards? It doesn't say anything. All we know is that we put down 3. But in this problem specifically, putting down 3 implies that we put everything down. And it also implies that the next person we're going to put down is going to be 4. So just off this information, we know everything. And that's why DP works here. Yeah, again, I'm not exactly sure how to prove this sort of lemma-like thing, but that's how it would work. And also notice that the cost for going to the office doesn't like change when you do this, because either way you still use the same set of keys. So DP at position last is the minimum cost to have it so you're at position. Yeah, you could use bitmask too if the ordering wasn't so fixed. That would be an example of bitmask DP, I guess. But yeah, you'd have 2 to the end state, and that's just not going to work. How do you do this? So this is the minimum cost to be at this position and have used the you've used this many people already. Then the answer is the maximum over all is the maximum. Let me see. The way to recover the answer is just the maximum over all j of, or maximum over all I suppose, of dp of I and the number of people you have, which is n. Because that's just the way it is. Like, it doesn't matter the final position, all that matters is that you've used all n people. Okay, how do we compute this? Well, let's see. To push DP or to not push DP? That would be the question. Suppose...
En La Esperanza hay un solo conectado nomás. No sé si eres tú.
Oh, yeah, right. Whoops. Sorry, the minimum. You're right. Whoops. It's okay. I would have gotten through the sample and realized that didn't make sense eventually. But yeah, it should be the minimum. Whoops. So the reason I find push DP so intuitive is because it uses the problem statement. With push DP, the transition is either you assign a person to here, in which case you get a new state based on that assignment, or you don't. That's why I think push DP is so nice, because you don't have to like reverse the transitions to figure out how things work generally. Push DP is where you explicitly use this state and like kind of push its value out to future states, like pause +1, last +1. Oh my god, that handwriting. Yeah. Jesus. But like, that's the idea. You use the state to push out that value to future states. I think that's the easiest way to do this. So DP pause last, you have 2 transitions. Either you take this one, or you don't. If you do, you end up with position +1, and now you use the new person. Or, this is problem E on my mashup, which you can find in the description. or you don't take it, in which case you have pos plus 1, but the last value is still the same. The base case here would be that it would be dp of 0 and 0. That's true. Indexing is very nice with push dp. I agree. dp of 0 and 0 will be defined as 0. And everything else will be equal to infinity. Because like we don't want to accidentally, for example, say that we're at position 0 but we've used one person. Because that could lead to an answer that is like not good. So we want to initialize everything to infinity to make sure we don't accidentally like see states that don't exist or something. But this is the idea. We're going to assign things in increasing order so we can do dp. It's kind of like, it's a bit like the dp from like, what would it be like the, actually no, it's not, never mind. It like resembles longest common subsequence, but it isn't. Okay, let's read in the values. LLP, so I'll read that in. And then we do that, and then we read in the first k values. And we want to sort them, because otherwise the ordering we do wouldn't make sense. We want to make it so they're sorted in increasing order, or non-decreasing. Then we define dp as follows. We have n plus, we have k plus 1 possible positions to be in, because 0 is kind of like a non-existent position, and same for this. This is like non-existent amount of people. And we have n plus 1 possibilities for the number of people. We can be within the range of 0 to n. So then we do the stuff. dpij equals infinity. That works, right? 110 to the 17th is big enough, yeah. So now let's go through. I equals 0, I is less than or equal to k. I didn't even work out transitions yet. Nice. Oh yeah, we did. So either we take this and then we get the cost of adding this person, or we don't take it and then we have nothing. So first, we don't take the person. Then it's just dp. I would welcome you, but I don't know how to pronounce your name still, so I can't. I plus 1 j is equal to min dp I plus 1 j dp I j. If this is infinity itself, then we just kind of ignore it because it's like the minimum of infinity and infinity. And then we do take person. This is only possible if we're not on the last person already. So if j is less than n, then dp I plus 1 j plus 1 equals min dp I plus 1 j plus 1 dp I difference between dp and kn. Well, it's just kind of like, it's just the array size. What really matters is how you define it, and I define it to be we're at this position and we've used this many people. And so we have 0 to n, like the possibilities for people are 0 to n, the possibilities for positions are 0 to k, so that's just kind of how it works. Push DP is what I'm doing right now. It's essentially the idea that instead of having DP recurrences rely on previous states, you instead use previous states to like push them out to future states, which is what I'm doing, kind of.
Gracias, César, por los likes. Gracias.
So this would be rely on DPIJ plus the cost, which is... No, not really. I mean, it's kind of the same. Like, you can just study whatever works for you, and it's almost universally going to be fine. Like, there's a very, very small amount of problems where, like, a certain kind is necessary. In general, both push and pull DP will both work. So this is DPI plus 1, J plus 1, DPIJ plus... the cost would be... Let's see, it would be the cost between... it would be AJ, the jth person, minus BJ. This is the distance between them. And then it's the distance between that key location and the position of the position of the yeah, push DP is more of a style choice than a concept. Like, it's not different, it's still DP. DP series next. I can cover, maybe I can cover the ACCODER, like the ACCODER DP thing in like a different video or something. Yeah, we can also define it to be like DP. We can also define it to be DP. I'm gonna do this in a different color. Like, for example, DP of IJ is like the minimum of DP of I minus 1, J minus 1 plus cost, and then DP of I minus 1J. This is a possibility too. I just prefer to do push DP like this. I mean, I prefer to do push DP because I feel it easier. Yeah, I'm not sure where the timestamp is. It's like near the very beginning, like before the 20-minute mark, I think. So this is the same idea. We have to add the cost here. So this is the cost of taking the person. And then, well, actually, for this, we don't even need the minimum, because no matter what, like, what we really care about is DP of K and N. Because any answer we would have already had before will continue to have it later on. So K is fine, and we need to have N people no matter what, so that's like what we need to do. CO, DP, K, and the fact that this is infinity doesn't matter because no matter what, we'll reach this anyway. So now we get 50, I hope. Or we don't. Did I do max instead of min? Nope, I did not do the base case, once again. I made this mistake before, and now I made it again. Where we explicitly define DP of 0 and 0 to be 0. Oh wait, someone asked in my blog or a different blog?
Yeah.
So we get 100. What? Did I do the cost wrong? 20 should go to 40. 100 should go to 80. Oh, it's the... Oh, okay. It's not the sum of times, it's the maximum used time. Oh, I misread that, okay. In that case, it doesn't change much. Then instead of this being plus cost, it's the, you consider it as the maximum of DP, I, J, and the cost. I don't get why it's 100 either, then. Is this still wrong? It feels still wrong. Wait, how did we get 100? Yeah, Yeah, okay, something's still up with this. And the idea is that what? 11 to 15 to 10, 11 to 7 to 9. What am I doing? Definitely missing something.
Gracias, Giancarlo, por los likes.
Oh, wait, whoops, this should be I. My bad. Yeah, we're taking the ith person. And this error doesn't actually make sense, but I do sort them both. Oh, that's another mistake. Sort this up to the actual value, not the previous one. I'm sure there'll be more such mistakes in the future. 69 viewers, nice. My Cofor's handle is Galen_Colin. You can find that. It's just my name, but like last underscore first. Let's see. We read the values in. We sort this by n. We sort this by k. Do the infinity and put everything to infinity. Make this 0. Iterate that to not k. Iterate this to n. Don't take the person, or we do take the person, and then the cost is the maximum of this and the time it takes for this person, because it's just how the problem defines it. It's the maximum maximum time anyone takes. And then the answer is dpkn. Yeah, okay. Looks right. Submit first, think later. Nice. Okay. So we do have wrong answer on test 5. That's interesting. In that case, what have I done? Is 1E17 big enough? Should be. Oh no, this should be this, I think. Is that? Yeah, okay, because the I is the position. My bad, my bad. More indexing errors, yeah. It's more of a typo than anything else, I just kind of like didn't think. Like, you know, you have those like brain typos where you just totally gloss over something stupid. Okay. Alright, so that was E. Before we move on to F, I'm going to grab some more water, because the more hydrated you are, the better of a thinker you are. So what I'm going to do is, I'm going to paste on a picture of a water bottle here, so that you all may boost your own ratings. And yeah, I'll be right back.
Llegó en vivo, se unió. Tiene razón, cantarle a ella. Luego besarla.
Llega en vivo, se unió. Tiene razón, cantarle a ella. Luego besarla. Damián Salazar. Damián Salazar.
I return. I did leave myself a note to unmute the mic. Okay, let me read chat, make sure I didn't miss anything important. Well, it wasn't a stick. It wasn't a stick, actually. What I did was I cropped this part, but I cropped it badly, so it was like this black part. Let's see. If DP is mysterious and confusing, look down how to do top-down DP because it's just brute force with memoization. Yes, I do agree with that. That is a very good way to think about DP, especially for beginners, because it's straight up just you remember the answers you already know. That's the whole idea of it. It's a great way to think about it, especially if it's a new concept to you. It's interesting how my viewership goes up when I'm not doing anything, and then it goes down when I do things. This is like a very weird dynamic of streaming. You guys can hear me, right? Have I been talking at nothing for the past couple of minutes? I hope not. Sanity check. Can you guys hear me? Let me check myself. Okay. A permutation P of size n is an array. I should just ghost the stream. Yes, I am 17. That is correct. Permutation P of size n is an array such that every integer from 1 to n occurs exactly once in this array. Let's call it permutation an almost identity permutation. If there are at least... Wait. Oh, okay. Almost identity permutation if there exists at least n minus k indices such that pi is equal to I. Your task is to count the number of almost identity permutations for given numbers n and k. N is up to 1,000, k is up to 4, which is interesting. Oh, this is problem F. I should update that. So the way this works is like... whoa, Demoralizer in the chat. How are you doing? Yeah, I do kind of have a deep voice. That is fair. So the way this statement works is, like, consider some array of length n, for example, n equals 7. And you got some stuff like, just consider the positions. A permutation is like any array so that every number from 1 to n occurs exactly once. So it's like 2, 5, 4, 3, 1, 6, 7 would work as a permutation. But if I replace this 7 with a 2, it wouldn't work because then 2 would occur more than once and 7 would not occur once. So everything has to be the same thing. Okay. That's what a permutation is. And an identity permutation is defined to be a permutation where every number is equal to its index. So they say an almost identity permutation is an identity permutation, but 3 or 4 of these elements but up to k of these elements can be out of order. Is this annoying casework? I don't like that. Wouldn't like if it's annoying casework.
Hola, ¿cómo estás?
But yeah, an almost identity permutation is, for example, this element can be something else, such as 6, which would force this element to be something else, because now you can't have the 6 be there. I personally am from the US, by the way. Sure, a lot of you are from India. That's what my analytics says. Like the vast majority of my viewers are from India. Which is why I'm streaming at this time, which is sort of inconvenient for people in the US, but it works for most time zones. Right? So if we have an almost identity permutation, the way this works is like, if we displace some element, then that means that this can't be a 6 anymore, which means it has to be something else. So either it's a 4, or it isn't. And let's see. Why does it have to be 4? That's not fun. Yeah, it would be casework. It would be some stuff like cycles. I have not been to IOI, no. I actually haven't even made I haven't made camp yet. I can try. I'm trying this year.
Buen día, hola, ¿cómo estás?
Yeah, these problems are random.
Buen día, hola, ¿cómo estás?
So either this is like a 4 or you continue it. But basically the way a permutation works is that it can be decomposed into cycles, where for example, say you swap these two elements. Then if you follow this element, like say you start here, and if you follow this element, you're going to end up here. And if you take some sequence of like going here, you'll eventually be able to come back to this element, and that's where you get a cycle. Most of these cycles are going to be here, where you just like go here and then back to it. Wait, who are you talking about? I definitely don't practice 6 hours a day. You mean Demoralizer? He's pretty good. Very good. If a kid with age 18 goes to college, can he participate in ICPC? I don't really know the rules for that. I haven't looked because I myself will be 18 when I do go to college. I don't like this problem. If M was 3, then there would be only one cycle. But the issue with N being or K being 4 means you can have 2 separate cycles. And that's slightly annoying. So I don't actually know what's up with that.
César Quispe, Enrique, Hoteles Dulce, 69, Richard y Josué.
Alright, what does this mean? Okay, most of the elements are equivalent.
Gracias, 69. ¿De qué se trata, Hoteles? Bueno, nosotros somos.
Yeah, I know. There's like. Why is this tag DP? That's my question. Why is this tag DP? Because I don't see it. I don't see a solution with DP. Well, actually, arbitrary K would just be like selecting some number of integers greater than 1 that sum to K, and that would be annoying, but it would be possible, I suppose.
Igual dale algunos consejos.
Todo eso se trata, ¿no?
I don't see how to do this with
Nosotros
DP.
usamos a los que es público
Does anyone-
conductor, pero también podemos
Does anyone in the
usar
audience actually know a DP solution?
Igual darle
Because there's a way to do it
algunos
with
consejos
math, and
para
that's
que no sean
fine, but...
complicados ni con los conductores ni ustedes.
Oh, is it like number of derangements? How'd this work? Derangement is a permutation that has no fixed points. Oh, I guess, okay, and choose K would be DP, that's true. Okay, that's, they count factorial as DP? Fine.
Para decirte por dónde hay alta demanda, porque ahorita alta demanda.
Oh, no, okay. The 6 hour thing, that's definitely not current. I practice like way less now. In fact, most of my practicing is just the videos I make.
Está por toda
But-
la avenida de la Marina con la Perla. Hay alta demanda en la Perla. Hay alta demanda en los...
Okay, I also said that 6 hours was an upper bound. It was not 6 hours every day. 6 hours was like maybe weekends where I didn't have much homework and I had a lot of time on my hands. And I just spent all of it thinking about problems, but that was not the norm. Maybe I did not make that clear when I said it. Yeah, 6 hours a day would be insane. You'd reach red in like less than around a year, something like that, if you tried that hard.
Por la avenida Las Flores, con la avenida.
No, I wasn't in the IOI team at all.
Por la avenida Las Flores, con la avenida...
I'm gonna eat something because my jaw is starting to hurt from talking so much. So,
Caja de agua. Por el caja de agua también hay
well, in terms of DP, I actually don't know how to do it. But there is a mathematical solution.
También hay alta demanda fuertísimo en Chorrillos, en ¿cómo se llama? En Barranco también hay alta demanda.
Yeah, I was not in the IOI team at all. I'm not sure if I have good chances of making it this year. Because despite my rating being high,
Por San Miguel, también puedes ir por ahí.
in terms of like Yusuko, like the competitors, like Yusuko is not.
Llego extra.
No, it's like I'm exercising my jaw because it's talking. I don't know. Maybe it doesn't help.
Con llego extra, no entiendo.
Llego extra. Pero ahorita con qué estás? ¿Con Diego o con
I did
Diego
say
extra? No
practicing 6 hours.
Qué raro, porque igual es como un socio.
entiendo. Así mismo no solo
Damn.
12 y 9.
Me imagino que es porque es
Es raro, porque igualito es como un socio más. O sea, no tiene nada que ver.
No, I'm pretty sure I would be an upper bound.
Pero me imagino que es porque es nuevo, ¿ok? Me imagino
Okay,
que
yeah.
es porque es nuevo, pero igual debe de sonar.
So at least n minus k indices that are in order
Pero por ahí
means that
hay
they're at
demanda
most
en estos momentos.
k indices out of order.
por el Agustino.
Hay una leve suma de alta demanda también
Pero por ahí hay alta demanda.
So there are 4 cases for k.
por el Agustino.
Let's fix k. We're interested in less than or equal to k, but let's just fix a number x.
Pero por ahí hay alta demanda.
Let's just fix a number x so that
Ellos me dicen
like in x positions, this is not equal to this.
Porque hay conductores como Daniel Panda, M, ellos me dicen que...
What gave me the motivation to start a YouTube channel? It was kind of just on a whim. Like someone asked me to. Oh God, are people from Blair here? Oh God. If so, why?
Está avanzando para el aeropuerto, ojo. Para el aeropuerto está avanzando.
It was kind of just on a whim. Like I'm pretty sure someone, I think Nietzsche, asked me to like do a screencast of like some Div 3, like around 661, and then other people from Blair. I hope not. Around 661, and like I just did, and then I realized that I liked it, and then I just kept doing it. That was basically it. There wasn't like some elaborate thing or anything. Yeah, what's up, Peter? I think a graduate, but still. What is my secret? That's a good question. I don't know. Like, I honestly wouldn't be able to tell you. It's just how you practice and whether you do it right. I did not have a strong math background, no.
Igual vamos a revisar qué es lo que está
I did practice a lot, at least in the past. I did practice a lot. Yeah, I do have math phobia, which is why I don't like this problem. But okay. So we say we have specifically x out of order, this exact number. So let's say x equals 1, and then, so like, let's say for example, let's say this 3 is not equal to 3. So let's say it's equal to 7 or something. But then the problem is, if we have this 7 here, then this has to not be a 7. But we can't make it not 7, because if we did, then we would have 2 elements that aren't the same. So for x equals 1, there's nothing we can do. The answer is 0. For x equals 2, we can do something like this. Say this is no longer a 3, then it's a 7, and then this would become a 3. And if it were anything else, then we would again have the problem where we have too many elements to change. So therefore this has to be a 3. Which means, how many more school years do you have? This is my last one, so I only have one more shot for IOI. So x equals 2 would mean that you're interested in the number of ways to pick 2 positions to put them out of order. Which is to say, you have this number and choose 2. X equals 3. Then you have 3 positions. But all of them have to be together. Here's why. Because, think about this, we'll do the same thing. And then what do I make this? If I make this a 3, then we have 5 positions now, but we only have 1 number that we can make wrong anymore. So if we do something like this, where we make this a 5, we can't do this because we've already used all the 3 numbers. No, there's like a explanation for being stuck in orange. I will, look, after I solve this problem, I'll talk about why orange seems more like a trap than it actually is. So basically the idea is if we make this anything other, if we make this equal to this, then we end up in the same situation as x equals 1. So this can't be a 3, it has to be something different, which means this will be something like 5. And then if we make this something else, then we have too many things, so this has to be a 3. And therefore we have a cycle of length 3. So we're interested in the number of ways to pick 3 elements to do some stuff. Okay, IQ or intelligence? That is a question. I think it does, honestly, because CP is pattern recognition. If you're inherently better at recognizing patterns, then you'll just be better at CP. Like that is kind of fact. So there is some sort of relevance to like there is some sort of relevance to how good you are at like pattern recognition and stuff. But it's not necessary. It'll mean you'll get better faster, but it's not necessary to get good. Because with enough experience, if you just like know everything, you'll just know everything and then you'll be able to do everything. So the more knowledge you have, you'll just be better. And even though IQ plays some sort of a role, it's not like a limiting factor. It's not like if your IQ is X, then your maximum possible rating is Y or something. It's not like that. Ever rule ors. Yeah, I agree. Anyway, for x equals 3, you have three possibilities. X equals 4, the final one. By the way, Demoralizer, I could ask you the same question. What What motivated you to inspire, or what inspired you to start your channel? Are you trying to demoralize people all around the world? Okay. So over here, basically, there are two possibilities. Either you can have this cycle be of length 4. For example, like, this can point to 5, this can point to 6, this can point to 7, this can point to 3. In which case, we have n choose 4 ways. That's not a shot, I'm just playing with your name. I do think your channel is really good. Because there aren't many like language specialized channels from what I know. Maybe there's AppCoder and stuff, but other than that, I don't know. And then otherwise we could have 2 cycles. So for example, we have a cycle like this, and then we have n choose ways to do that, n choose 2 ways to do that, but now we have n minus 2 elements and we want to pick another cycle of 2 elements, so it's just n minus 2 choose 2. So the possibilities here are n choose 2 times n minus 2 choose 2. Okay. This is basically the answer. We just like sum up all of these, right? So how do we compute n choose k? We use the formula n choose k is equal to n factorial over n k factorial times n minus k factorial. What is happening? One year is a long time. You could learn a lot in 1 year. For example, maybe I'll know F15 in a year. Probably not, but I might. Who knows? Anyway, we define this function factorial n to be defined as n times factorial of n minus 1. And this would be how you could do n choose k, but like don't do that because like just don't. Because this is like too big. You're gonna overflow if you compute factorials. And I guess you could actually think modulo. Look, I think the way it works is because n choose k is always an integer, if you compute it modulo something, then even though you did it the modulo, it will still be an integer. And therefore if you use a modulo, it's gonna work out. But there's like just a better way to do this. Like n choose k is equal to n times m minus 1 times m minus 2 times m minus 3. Or m minus k. Dot dot dot. And this is over 1 times 2 times 3 times dot 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 times k. And that's like the formula you can use because then it won't overflow.
Por ahí va a haber zona garantizada, ojo, por ahí va a haber
Okay.
zona garantizada.
So, oh yeah, I guess true. Because the numbers are big enough for that to be a problem. Alright, but what does this have to do with DP? I guess this is...
Por ahí, pero por todo el circuito de playa. Por todo el circuito de playa. Ahí va a haber
I guess this is just the thing.
Zonas garantizadas.
I think this is the formula for like number of derangements or something. So you can use some sort of DP approach to derive these formulas instead of like thinking about them, I guess. And this would be the derangement's recurrence or something. I don't know. Is that how that works?
A veces en los
I guess it would be, but that's basically the idea.
en la zona morada,
So,
en sí, o en la zona
let's implement this first. N choose k is defined to be this numerator.
que son los multiplicadores. A algunos le aparecen lo que son los multiplicadores. ¿Qué son los multiplicadores? Pues son tarifas, no, o sea, son un plus para las tarifas. Igual, cuando hay multiplicadores, las tarifas pueden ser mucho más altas. De un viaje por
And now c into n to k,
soles,
if k
la tarifa
is less greater than or equal to 2,
a veces cuando es multiplicado por 2, pues aumenta el doble, que son 10 soles, ¿no?
yeah, the binomial coefficients you can do with dp.
Por eso. Eso es una falta de masa.
And it's plus equals nck and 2.
Hay zonas donde los horarios son de 6 a 8, de 6 a 10, después de 5 a 8 o 7 de la noche. Más o menos en esa hora están los multiplicadores, en donde prácticamente los usuarios al tener urgencia van a hacer estos tipos de viajes y ustedes se van a salir beneficiados.
That took way too long. Jesus. Actually, most of it was answering questions, so I guess it was fine. And we get 0. Oh, wait. 1 because the identity permutation itself is a permutation.
Ustedes tienen que acercar más o menos en esa zona para obtener esos precios.
12. Fun. Okay. Y. What is... What? 4 times 3. Should be greater than? I guess it would be greater than. Yeah, okay.
¿Qué oferta también te da hielo? ¿Qué ofertas otras ofertas?
21. Oh, come on.
Nosotros aparte que te damos juego premium, ¿no? Que es en general los beneficios y todo eso. Bueno,
Oh, it's not even that, because you can also pick the elements in whatever order you want.
Te damos atención vivo.
Oh my god. I don't want to rewrite this formula, but basically the way to fix this is just to like get rid of this part. Like it's just this. I'm pretty sure.
¿Cómo lo puedo ganar? Pues muy fácil. De lunes a
Or not.
domingo haces tus viajes. Si haces tus viajes de,
Or not. Okay, wait, what?
Entre 20 viajes a 49 viajes, pues estás dentro del sorteo y eres parte de Yego, ojo, y eres parte de Yego, estás dentro de los 5 premios de
I'm very confused now. Have I done this wrong somehow?
Entre los viajes de 50 a 99. Estás participando para los 5 premios de 50 soles. Y si estás entre los viajes de 100 a más, estás participando entre los 5 premios de 100 soles. Sí, también tenemos lo que son los
Yeah, but I'm overcounting somehow. Is the thing. Like I'm already overcounting.
En el cual tienes que hacer 10 viajes.
So I don't exactly know what's causing that.
10 viajes, pero en ciertos horarios, que son de 6 de la mañana a 7 y 59 de la mañana.
Yeah, I guess that's true. It's not exactly equal to that.
59 de la mañana. En el rango de ese horario o de esas 2 horas tienes que hacer, pues,
Guys, this is why I have math phobia. This is justification for not liking math.
También, si cumples esa meta, también estás dentro de los 5 premios de 100 soles. Así que Yego tiene muchos premios para ti, no te lo pierdas.
También, ¿qué es Yego Premium? Ojo, ¿qué es Yego Premium? Yego Premium es un programa en el cual Yego solamente...
También, ¿qué es Yego Premium? Ojo, ¿qué es Yego Premium? Yego Premium es un programa en el cual Yego, solamente el socio Yego lo tiene, ya que hay muchas inseguridades en las calles, ¿no? Y aparte de que un conductor puede estar en apuros en sí, ¿no? Por ejemplo, un ejemplo.
¿Ya? Por ejemplo, tu carro.
Diego tiene lo que es grúa copago.
Tu carro está varado.
Copago que es un 50%.
No,
¿Ya?
¿qué vas a realizar? Pues no.
Por ejemplo, tu carro está varado. Ya tu carro está varado.
Wait, okay. I'm gonna re-explain this after because I'm kind of confused myself. I think this whole thing is wrong.
Llamas a una grúa,
Tienes que grabar.
llamas a una grúa, trasladan tu vehículo, ojo, el vehículo
That
tiene
is
que
indeed a
ser el que
possibility.
está registrado en nuestro
Y el
sistema.
momento de que
Tienes que grabar cuando están trasladando tu vehículo, mostrando la placa y todo.
agarras y
¿Sí?
traes tu...
Y al momento de que ya hayan trasladado tu vehículo y hayas pagado todo lo de la grúa,
Tienes ya
agarras y traes tu boleto. Traes tu boleto, tu factura, cualquier el otro. ¿Sí? Tu boleto, tu factura. Tienes ya cumpliste los 4.
Okay, so this can go both ways. So it actually needs to be 2 times this. And then this formula is even more complicated.
Ya, chévere. Aplicas. ¿Y qué es lo que te hace Diego? Te da el 50% de lo que has gastado en la grúa.
No.
Ese es uno de los beneficios.
Yeah, I see what you mean.
De lo que es grúa copago.
How would you even do derangements? There's some DP for derangements, right?
El pasajero bajó, ya uno viene, ya son 11 minutos. Has colocado en espera, te ha salido la opción en espera.
Sí, primero llama al usuario.
Ahí tienes que colocar el botoncito. Marca el botoncito en espera.
Sí,
llama al usuario.
Sí, ya voy a
Y
ir.
primero llama al usuario.
La tarifa va a incrementar.
Colocas el botón de espera. Y si el usuario te dice sí, ya voy a ir, pues la tarifa va a incrementar. Y el usuario te va a tener que pagar lo que incrementa la tarifa, siempre tú.
Derangements of 4 elements are 15. Okay, I'm gonna trust that. What?
Colocas en espera, luego llamas al usuario.
Primero
Wait, what?
agarras, colocas en
Let me just look this
espera,
up.
luego llamas al usuario. Y si dicen no me va a demorar
Yeah, I'm still
5 minutos
struggling.
más o
It's
algo,
more accurate.
igual, la tarifa va a ir aumentando.
Oh, you can use pi? Okay.
Hola, Chani.
Oh my god.
Hola Chani, ¿cómo estás?
Mira, señores, ya me salió a mí, por ejemplo, ya me salió la zona multiplicada. La zona multiplicada ya me salió.
Mira, señores, ya me salió a
There are
mí,
9
por ejemplo,
derangements? Okay.
a mí ya me salió la zona multiplicada.
I'm gonna trust you
La
guys.
zona multiplicada ya me salió a mí.
I wanna go back to like the standard things that are chill and just like normal DP and not bashing out math. What difficulty is this? Oh wait.
Está en toda la avenida Perú.
Okay, does it work?
Está en toda la avenida Perú.
Alright, fine. So here, let me explain how the hell this happened.
Carmen de la Legua Reynoso también está en...
Yeah, Wikipedia has a table. Alright. So say you have a permutation. I guess there's a less complicated way to say this. Say you want one element to be out of order. Like you can't do that. Because like one element just can't be out of order. But say you want 2 elements to be out of order. Then you can do something like this. Where it's equivalent to the number of ways to pick 2 elements and then the number of ways for them to be out of order. Yeah, sure, I'll try and derive it. So the first thing is n choose 2, but then you need to know the number of ways for it to be out of order.
También hay zonas multiplicadas, señores. En todas las zonas hay zonas multiplicadas.
It's not wrong answer. So n choose 2 times the question mark. And for x equals 3 and 4, it's the same thing, I guess. You would want to pick 3 elements and 4 elements, but how would you do that?
Hola Brando.
Because now you need to find the number of ways to make 3 or 4 elements out of order.
Hola. Hola, Brando.
So let's say you do something like this. You have a permutation of 1, 2, 3, and 4, for example. Let's define some function d of n that represents the number of permutations where every element is not equal to its index.
Un ratito, ahorita vengo, señores. Un ratito.
You can do this in many ways, I suppose. You can do it with, for example, like inclusion-exclusion principle, where you say that like all 4 elements are out of order, and like, or at least 4 out of order, at least 3, at least 2. I don't know. But here's the idea, I guess. For this element, it has to be something not equal to itself. Let's say, for example, it's 2. And there are 3 possibilities for that. How would this work now? So I guess this could be a cycle. Oh, this is painful. So this could either be 1, and then this would close off the cycle. And there's one way to do that. And then you would have d of n minus 2. Or it could be not 1. And then you'd have 2 ways to do that. For example, it would be 3. And then you would have more things.
Hola Simón y hola
Hola. Hola, Simón. Y hola.
Hola.
Juana.
Hola DXR, ¿cómo estás?
Is there occurrence? O of n?
Hola. Hola DXR, ¿cómo estás?
¿Cómo estás? Dime, ¿tú eres usuario? ¿Tú eres conductor?
I guess this would...
¿Cómo estás? Dime, ¿tú eres usuario? ¿Tú eres conductor? ¿Qué te dedicas?
The place being not 1 means you can consider 1 as 2. That place, okay, well this is well researched anyway, but that place being not 1 means you can consider 1 as 2. And use derangements of n minus 1 for the rest of the array.
DXR, dependiendo, ¿estás con nosotros en Yego? Si estás con nosotros en Yego, por favor escríbeme el interno a Yego en vivo, ¿sí? Y déjame tu licencia.
Consider 1 as 2.
Déjame tu licencia para poder ver
Confused.
tu perfil, por favor.
Primero yo voy a fijarme si estás en Yego Premium. Si estás en Yego Premium, pues
En este
tienes
caso,
hacer la
lo que
denuncia
deberías de
o
hacer
denuncia
en sí,
correspondiente. Sí, tienes
primero
que
yo voy a
hacer
fijarme si estás en Yego
el-
Premium. Si estás en Yego Premium, pues tienes que hacer la denuncia correspondiente. Sí, tienes que hacer el bloqueo de lo que es el chip,
en las oficinas,
el
o
Gmail.
si no lo traes mañana en las oficinas, puedes ingresar
Ya, y
al
traerlo
correo que
aquí
tenemos
en las
aquí arriba,
oficinas, ¿sí?
al más
Te lo traes
169
mañana
23 15
en las
122,
oficinas,
con la
o si no
palabra
lo traes
Yego
mañana en
Premium.
las oficinas,
Pero
puedes
primero
ingresar al
quiero
número que tenemos
verificar.
aquí arribita, al más 1669 23 15 122, con la palabra Yego Premium. Pero primero quiero verificar.
Mira,
Are we getting the generating functions? Okay.
bueno, no es
Ahora
ahora.
me
Te
robaron
hubieras
el celular.
conectado una hora después, te hubieras conectado en el evento.
Alright, whatever. I don't want to do this anymore. There's some way to figure out the number of derangements. It's like some formula.
Pero te hubieras conectado una hora después, te hubieras conectado
Something like this? Okay, sure.
nuestro amigo también Yandro, y él te hubiera podido ayudar. Pero espera un ratito. Vamos a
How does this work? N-1 makes sense. You put that element down. Okay, well anyway, I kind of just hard-coded the formula anyway. But the idea for this is that there's some way to count the number of derangements, and that is exactly what you want. And it's based on DP or something, like recursion. Yeah, I know. You have N-1 choice for the first formula, and then you like do some stuff. And then once you do this, it's like...
Si estás en Yego Premium, lo que ahorita tienes que hacer, ya, sí, prácticamente...
Then this would be...
Si estás en Yego Premium, Harold. Si estás en Yego Premium.
The answer here would be D of 3 and D of 4, because it's the number of ways to have 4 elements be out of order, and the number of ways to pick those elements.
Han apagado el celular todo y
eliminado el aplicativo.
ya no está.
Yeah, if it goes into 1, it's D of N-2, otherwise...
Como si hubieras eliminado el aplicativo, ¿sí? Lo que ahorita te recomiendo es que
Oh, I
hagas
get
la
it. Yeah,
denuncia.
okay.
Hagas la denuncia
Sure.
antes que pase las
That's like
24
too
horas.
smart for me.
Haces la denuncia.
I understand.
¿Dónde está el chamo? Ahí estás.
I understand, but I don't want to explain it because it's not that relevant. Actually, whatever. I guess I can. Here's the idea that Gabe et al. Are saying.
¿Dónde está el chamo? ¿Dónde está el chamo?
To count the number of derangements, that is the number of permutations where every element is not equal to its own index. First of all, you have to put this like the element you put here has to be different from the original one. So this would be, for example, you have N-1 ways to put down the first element. And then wherever that element is, either this is the same as this one, which is like, for example, this. And then in that case, then you have just N-2 elements remaining. So you have D of N-2. So one possibility is D of N-2 times N-1. And the other possibility is you have, it goes to somewhere else. Because this has to explicitly not be 1. Which means in the context of this, you can kind of replace this with 1, because this has to not be itself, and then you're looking for the derangements of that. That's what people are saying, I suppose. So then in a similar manner, you have D of N-1 times N-1, and then you sum those together and it works out. Okay. Yeah, you people are too smart for me. Let's be done with this and do more chill things.
Sí, eso sería todo. Y te van a estar contactando después de 10 días. Te van a estar contactando ¿para qué? Para que te hagan la devolución de lo que es el celular.
Okay, we are on to G.
Para darte una respuesta en ese aspecto. Darte una respuesta para ir o citarte el día en que te van a dar el celular.
pero eso lo tendrías que hacer desde el mismo aplicativo.
The onboard computer on Polycop's car measures that the car speed at the beginning of some section equals v1 meters per second, and at the end it is v2 meters per second. We know that this section of the route took exactly 2 seconds to pass, assuming that at each of the seconds the speed is constant, and between seconds the speed can change by at most d meters. Weird Facebook notifications. For a second absolute value, find the maximum possible length of the path section in meters.
Me escribes el número nuevo que quieres cambiar, ¿sí? Ya sea prestado, por ejemplo, el número de tu esposa o de alguien, ¿sí?
Sí. O sea, por lo que
Interesting. Okay. So this kind of screams DP. And the idea would be that here's the statement in short. Essentially, you have some starting speed, for example 5, and then you have some ending speed, for example 6. And you have like a lot of moments in time where things just happen. This is way too many. You know, a lot of moments in time where things kind of happen. There's a lot of research that goes into derangements, I suppose. Yeah, anyway, I'm not gonna bother with that anymore.
Enrique, es algo que escapa de mis manos porque está como descartado. Tu cuenta está descartada, Enrique. ¿Sí? Y es algo de que, bueno, soporte tiene...
No, my math teacher does that. It's kind of like, it's kind of funny. He just like wildly varies his voice at times. So that's just what I did too. So in 1 second, the speed, there's some value d, and in 1 second the speed can go like in any range from 5 plus d to 5 minus d.
Hola Pedro, ¿cómo estás?
And that's the idea. So now what do we do essentially? We want to figure out the maximum possible sum of numbers, essentially. I think. Did we count the last one? Yeah, I guess we would. It's the maximum possible sum of numbers. So, let's do something like this. Say we're at some value, we're approaching this like a DP problem, remember. So what we want to do is we want to figure out some state that fully represents the problem. So say we're here, which means we've already solved for the prefix of the first I times. So the DP state has to include the position, which would be I. But at the same time, what else would happen? Well, it would be the case that the time, like the speed that you can have here, is solely dependent on the previous speed. Because the speed you can have here, like all that matters is, is there enough time to brute force this? They give it 1 second. No, it's not brute force, I mean it's like stuff. So the speed this would be solely dependent on this. So in reality, we just care about the position and whatever the previous element is. Because when we're figuring out what matters for this state, we don't care about this. All we care about is this one. So let's store the position and the previous value. And that's enough, because with that we can fully and uniquely determine what we have to do in this current state.
y y yo te doy el número.
Do you enjoy it when I suffer on problems? Because that was the case last time. I do tend to do that a lot. So a DP of I and the previous element would be like, what's happening here? My train of thought is like, it's not only off the rails, it's like flying at this point, so I don't even know what I'm doing.
Nosotros en Yego, sí, para poderte dar los datos, Pedro.
Primero tengo que saber si estás con nosotros en Yego, sí, para poderte dar los datos
So,
Pedro, o sea, la información correcta, porque cada socio maneja distinta información.
basically what happens to DPI previous, let's do the push DP again, because I like doing that. I do love when I don't struggle, but it seems that other people love it when I do struggle, so there's some fun in that. DPI and prev can be pushed to any value where any new value. My OBS disconnected. Is the stream still? Wait. Is the stream still going? What just happened? Are we good? Or are we not good? Okay, cool. Wait, let me check if it ended on Code Forces. That could have been a glitch. Okay, cool. Wait, let me check if it... And my voice is loud. Yeah, it said my OBS crashed, and then it said it came back up, so I don't know what happened there. Wait, the quality's down? Seriously? What? What does that even mean? It still says... Wait, okay, what the hell?
Mira, yo voy a hacer reporte.
What just happened?
Pero al momento de tú recuperar tu cuenta también tienes que hacer el reporte como conductor.
Wait, maybe it might have reset your quality. Try like clicking the 3 dots and setting it to this specifically. That might be what's necessary. I'm gonna set it to lower for my own because I don't want to lag it too much. Is it fine now? Okay, cool. Yeah, refresh if you have to. It may just like be glitched or something. Yeah, that was annoying. It just said my OBS disconnected and then like for no reason at all, and then it came back later. So hopefully it's still good. I've done streams this long before. My computer hasn't had a problem with it. I don't know. But anyway, like obviously we can get to any value between these two. And then the value we get is just this value. So that's essentially the way this works. And we want to find the maximum possible sum. So the base case here would literally just be like the first element with the first value. That's all we can do. And, okay, how do we do this? First of all, because we want to maximize the sum, there's no point in going below 0, since both ending times are above 1, or at least 1. So we can assume that all values are greater than or equal to 0. Actually, greater than or equal to 1, but I'll just do 0 because convenience. And at the same time, t is 100, and d is less than or equal to 10, which means that like the maximum speed we would want to do would be like around 1,000 or so. Okay, stream's probably gonna go on for a while. You can like leave if you want, because the archive is gonna be up anyway. I guess it won't be the same fun as the stream itself, but and the content itself will be up later. And I'll also put timestamps and stuff. Right now we're on problem G. I'll put timestamps and stuff so everything will be visible quite easily. Let's see. So this is 10. Right? So like this value is at most 100. And this value is at most 1,000. And this transition affects at most like 21 things. It might be longer than 30 minutes. I don't know. Some decent amount of time. Probably get through at least one more problem. I'm definitely not finishing the mashup. Maybe I'll continue it later in like a separate stream or something. That could be a possibility. No, they are not. They are not sorted by difficulty. A to D, well, A to D are the easiest, but then E to O are completely random. So, for example, that's why K has 13 solves. Okay, I'll finish on H. Facecam at 10,000 subs. That's the deal. It's not on, right? Better not be on. Look guys, the deal is simple. We need 5,600 more. It better not be on. I have my own stream open. If I would be very concerned if I missed that somehow.
Depende, ¿sí? 69, por ejemplo, ya
See, I actually have 51 viewers right now because one of them is me on my phone, so I can read chat.
Así que te dan la opción de llegar hasta el menos 50.
No, face reveal is 10,000. I don't know where did 8,000 come from?
Y también advirtiéndoles que si están con saldo negativo.
I'm doing a special video at 5,000 though. It's gonna be one of those like clickbait things like the journey video. It's gonna be great. Anyway, for now, let's do this. So we can assume this value is at most 1,000, and in fact, it's around like at most 600, because you can spend 50 turns going up, but then you have to spend 50 turns going back down, since the ending value is also around 100. But let's just assume 1,000, and then we'll do something like this. So start and hello, what is it? And okay, I'll call it D. Then we'll do DP and 1,000. Yeah, I did have 4.2k yesterday. Streams do wonder for this. Streams do wonders for this channel, because like I had 180 viewers at some point, and they were all watching me fail to pin a comment on live stream. Like, look at this. What's that? The Code Forces stuff does wonders for viewership. Like, these numbers are crazy.
Y son los 5 soles que te descuentan muy aparte de lo que son los bonos.
Okay. So,
claro que sí,
we'll define infinity again. No, should be negative. Because we want to minimize. And the base case is dp at 0 and start equals 0. And then the answer will be dp of n minus 1 and like the ending value plus the value itself. Y para que ellos estén al tanto. Igual te pido que hagas lo más rápido posible la denuncia para que okay, so lo que es el bloqueo del chip, el bloqueo del Gmail, para que lo traigas aquí a las oficinas el día de mañana. Igual te dejo por interno nuestra dirección para que te acerques con todos los papeles, ¿sí? do I think of Ava's comments? I feel like some of them are unnecessarily mean. Don't get me wrong, they are funny, some of them, but at the same time, like, I don't know why anyone would just want to be mean like that. It's kind of like a... It's like a, what is it, like a mixed bag or something. Some of them are great, some of them aren't. I don't know. So dpi plus 1, j plus k equals max dpi plus 1, j plus k. Dpi j plus the value itself, which would be j. And this would be negative infinity if we can't reach it. dpn, and I think that works. Does not work. I did do the base case. Wait, what? Yeah, and j plus k is less than 1,000. That's not the difference. Well, the state, okay. The state transition, like, following the rules of the problem, it's kind of simple. Like, you can make this number, you can make the next number be anything you want, provided that it's within d of the previous one. So that's how you just derive the transitions. Use what the problem, like, tells you to. Do whatever, like, operation the problem has you have, or whatever you need to do for the next element or something, just go by the problem. And then any transition that works will be defined by the problem. And of course, like, you want to add j, except, like, this is totally wrong. I don't know why. And I'm confused now. What is happening? N, D. Should be M-2 or something? Wait. I mean, it should be that. This doesn't make sense. Okay, some sort of index bug. That was quick. You know, I still have the chat open. Please don't be annoying, because I can still do things. Please make a video on geometric algorithms. You know, when I proposed the topic stream idea, like this thing I'm doing right now, geometry was actually the thing I had in mind. But, like, the reason I'm doing DP is because, where is this? Like, we just go here. I made this poll, and then I asked everyone what they wanted to happen inside this thing. And just, like, look at this. Like, 800 votes, and 66% of them were DP. There's no way I couldn't do this. It helps to have mods for stuff like what exactly just happened right now. That, like, things just, like, people spam or something and it's kind of just weird. And it's nice for me to not have to look at chat all the time to just see what's happening. Tricky and crazy DP optimization, stuff like divide and conquer. Aliens trick, maybe? I'll have to study for that, but I could. Maybe some sort of, like, advanced DP section or something. That's a possibility. Why is this wrong? This is my concern right now. DP 0 start is equal to 0. For I equals 0, I is less than n, I plus plus. For j equals 0. Check my code forces inbox. What happened there? Wait.
Acabo de mandar los requisitos. A ver.
Ya, te acabo de mandar los requisitos.
Estoy en otro socio. Claro que sí.
I'll respond to that later. I think that's a good idea. You could also just ask me here if you want it to not be a secret.
Claro que sí, escríbeme el interno, César Guevara. Escríbeme el interno.
Llego en vivo, por favor.
Yeah. What really is going on here? What's inside this message?
Llego en vivo, por favor. Llego en vivo, ingresa al aplicativo. Voy a ver si es que te puedo escribir yo. Un ratito. Listo, señorita. Ok, señor JJ.
Okay, so
César Guevara. ¿Te escribí?
yeah, let me figure out what's happening right here.
Solicitar dos cositas.
Te escribí, César Guevara. Te escribí. Te voy a solicitar dos cositas primero.
Why would it be negative infinity when it's like not? Start exists, right? Like we're reading the input. This context is that I'm basically doing a bunch of problems and they're all dynamic programming. And so right now I'm trying to figure out why this program is wrong because it doesn't make sense. But the rest of the video is all about dynamic programming. That's the idea. I'm picking a specific topic and like going ham on it.
Hola, habla causa. Habla causa. ¿Cómo está? Por favor, ayudarme para resolver esto. A ver, un ratito, ¿sí? Te escribí. Te respondí de XR. Te mandé los requisitos para que estés preparado. Igual te voy a... Aquí te voy a mandar un ratito. La dirección de la oficina, ¿sí?
What the hell? Okay, time to print everything maniacally. Let's have this go up to 20, so it doesn't matter. How? How did that make it segfault?
No me contó unas carreras para el bono y yo hoy 2 carreras más. Voy a hablar cosa, escríbeme el interno.
Maybe it's this. Do we only go here? What does it want? It shouldn't be a problem. What? Wait, if I... No, this is fine. The fact that it's 0 is fine, because I'm doing it weirdly where I count the start here instead of here. I don't think that part's the problem. The problem is that... Wait, okay, wait. If I make this equal, then the problem is that it's accessing this out of bounds. And somehow that changes the original values of the array? Bruh, segfaults are weird. Like, if I make it so it changes less values, it makes it correct. If I make it do strictly less work, it makes it correct. Even though I'm doing maximum here. That's so weird. Other videos for hard DP? Probably in the future, yeah. See, this one is just a trial run. I just wanted to see how this would go, and seemingly it's going pretty well. Okay, I guess this works. Oh. I guess the segfault just made it like access the memory that already existed or something? I don't even know. Anyway, don't segfault. I guess that's the lesson.
Ya,
If you want to see explanation of G, you can rewind the video. Does it let you actually? How far does it let you rewind on a stream?
Ya. Mira. No sé si es por falla del GPS.
Ya.
No sé.
Mira.
This started about 25 minutes back or somewhat.
GPS.
So you can rewind 25 minutes and I think I do explain the statement, I think. Okay. I'll do H as the last one. Possibly in another stream I'll continue this mashup.
Colocó llegué antes de llegar al punto y lo has culminado.
Okay, but this will be the last problem I do.
Después del punto.
Kind of getting tired right now. So we'll leave it as this.
El otro es que como que colocaste llegué, avanzaste como 5 o 6 cuadras y es como que comenzaste y terminaste ahí mismo. Comenzaste y terminaste ahí mismo. ¿Ya?
Circunvalación.
Y el otro es como de no sé si el GPS habrá fallado en ese momento, no sé qué es por la avenida Circunvalación.
El 14 de julio. El día de hoy.
Ya que
me imagino que
no, que fue el 14 de julio.
No se ve ni
One 14 second.
De julio, el día de hoy.
Cuando colocaste comenzar.
Me imagino que el GPS te habrá fallado porque no se ve ni cuando colocaste llegué,
what is going on
ni cuando colocaste
in this problem?
Comenzar viaje ni nada de eso.
También que fue el día de hoy.
Fueron 3.
Admittedly, I am losing my focus right now, but I mean, it kind of comes from experience. Like, Yusuko is 4 hours.
El día de hoy, que fue a las 5:44 de la mañana, que fue en el jirón Lucanas, distrital de la Victoria.
Yusuko is 4 hours, so I have to be mentally prepared to be able to do that. And like, Code 4's contests are 2 hours, so going until 3 hours isn't that bad of a stretch. I've done 5-hour streams before, and those were terrible. But this is relatively fine. You say K? We'll see, we'll see. It's the middle of 2018, false, and Maria Stepanovna, who lives outside, I can't say this, who lives outside of town, wants to rent 3 displays to highlight an important problem. There are N displays placed along a road, and the height of them can display a text with font size SI only. She wants to rent 3 displays with indices I, which is less than J, which is less than K, such that the font size increases if you move along the road in a particular direction. Interesting. Okay.
Este es el punto de recojo y este es el punto de destino. ¿Ya?
So the idea is as follows. Let's. Actually, wait. This isn't so hard to solve. This isn't as hard to solve as to find a good way to explain this. So let's figure this out.
Es como que tú colocas llegué aquí. En el punto de recojo, tú colocas llegué aquí sin estar en el punto de recojo que es aquí. ¿Ya? Luego avanzas.
If you have a link in a message, I think YouTube like automatically removes it or something. I thought I had that setting to not happen, but apparently it does anyway. So I don't know.
En sí, eso es lo que ha verificado ya. ¿Sí? Y el resto sí, es obvio. El día de hoy no te lo iban a reconocer por ese motivo.
Okay, so this is problem H. And the idea with problem H is you have 2 arrays. One array is an array of values, font sizes, okay. And the other array is an array of 30,
Pero son 3 viajes
20,
nomás, o sea, ojo, son solamente 3 viajes que
10,
no están contando.
40.
No son más.
Basically, you want to pick an increasing subsequence of size 3, such that the sum of costs of the elements in the subsequence is minimum.
Pasarme llego. Claro que sí.
Right now, I'm doing problem H.
Consulta
So you want to do this.
de socio.
So you want to pick this, pick 3 elements so that the cost of the 3 elements is at like minimized, right? So the idea here is that if you're at some element, so again, we asked the question, if you're at some element and you want to put this element in a sequence, say, like what matters about it? So there are 2 possibilities. This element is the beginning of a sequence, in which case this is element 1, or there's some other sequence that this extends. So therefore we'd have to extend some sequence before it. Also, the basic idea here is that brute force isn't going to work because n cubed doesn't pass, but that's irrelevant because you could either begin the sequence here or extend a sequence from a previous one. So to extend a sequence, this previous one has to have been the last element that was placed in the sequence. So why don't we do it like this? Let dp of I, where I is the position, and let dp of I be the number of things where this is the last element, or I is the last element in the sequence. Or not necessarily the last element, but the last element that's been placed so far. And then we can say that, well, we also care about the fact that the sequence is of length at most 3. So let's do something like so, where we also include the number of elements that have been in the sequence so far. Len, for example. So actually, it wouldn't be that I is the last element, it's that I is at position len in the sequence. Then this would be the minimum cost to make this happen. Right, okay. Now, how this would work is, again, the transition is either you, I'm going to do pull dp here because I don't know, why not? The transition is either you begin sequence, then this would be dp of I1. Because it's the first element, and then it's just the cost of that element. Or let's say ci. Or extend. Then it's dp of I k is equal to some previous value j in the previous position plus ci. And essentially, this value j must be before I. So it's under condition that j is less than I. But like that's it.
Son detalles en sí que Django pone como requisitos para que podamos tener el bono.
That's it because that's just the recurrence. Either you begin the sequence or you extend one. And if you extend one, then it depends on some previous dp value. So let's do that. What will this be? Same to n. And this would be the cost. Then what will this be? dp of n and 3, or n plus 1. for j equals
Y
1.
Uber hace eso, ojo,
With 2.
Uber hace eso. No sé, yo
So then simply dpi 0 is defined to be where it's the 0th position, so it's just the cost.
No voy a hablar mal porque el carro limpio
K equals 0, k is less than I, k plus plus.
Pero me daba como un vueltón. Prácticamente
So then dpi equals infinity. Let's just initialize it to that.
No me gustó eso.
And then it must extend some other sequence, so it would be dp of jk minus 1, dpij equals min dpij, dpi
En ese caso,
dpk
si es unas cuantas
j
cuadras
minus
más,
1
le podemos
plus
decir que
ci.
es una parada. No le van a subir mucho, le subirán
And then ants equals min ants dpi
pero
2.
tiene que agregar
Because we can have it so, because this is the sequence where the length, the thing ends at I, we have to consider all possible endpoints, so the answer would be the minimum over all dpi and 2. If no such sequence exists, then we'll print -1, which means the answer would still be infinity.
Se lo puede sugerir al usuario. Mira, sí, normal, pero mira, para que no me perjudique, agrega una
We get 60, which is somehow wrong,
que lo puede hacer hasta con su mismo GPS y tú avanzas.
because I don't actually check. Right. If a k is less than aj, strictly less, that's the condition.
En el chat del aplicativo, en servicio de asistencia, también lo reportas indicando de que o bien el usuario no sabía cómo cambiar el punto de destino o una parada, o no quiso, ya si te
Strictly less.
el punto donde el pasajero le
Why is it not behaving like strictly less?
¿no? Lo reportas.
I equals 0, I is less. This should be I, not j. Whoops. Should be 33. Looks right, I think. We use I here, I, J, K, I, J. Yeah, I believe in it. I believe it's probably wrong. I don't know. Doubt is a thing.
Muchas gracias por tu apoyo, de verdad.
Okay. You said you want me to try problem K?
Siempre es
I can do problem K and that can be the last problem and I'll end the stream here. Or something. Because this is probably enough for everything.
¿Para qué? Para que no te perjudique.
But alright, so... Okay, this is flavor text, I'm going to ignore it because I'm not ready to do anything. Sequence of L integers, where it's increasing, is... Yeah, okay. So K is going to be the last problem I do, and then I'll end the stream here. After that, we'll leave the harder problems for later. Although I suppose E was also a relatively hard one. Although most of these are going to be the worst. So the next stream will kind of be more of like an advanced section, I suppose. That will work that way. And then maybe we'll do some custom problems or something, which are probably going to be even harder. So that's fun. Alright, sequence of L integers is called good if each number divides by the next number by the next number of the sequence. Wait. Okay. Each number, yeah. Divides by is like confusing, but each number divides the next number. Given n and k, find the number of good sequences of length k. Okay, sure.
¿Cómo estás? ¿Qué tal tu domingo?
So once again, we figure out the way to derive the state. What are we going to build the DP on? first we have to include the position, as always. And then say we're putting some number down. For example, we have like 2, 2, 6. Yeah, this is the last problem. It's going to be over after this. And we want to put some number x.
Bueno, verifico también que solamente te falta un viajecito para que llegues al segundo bloque, bueno, al otro bloque, al siguiente bloque, que es de 235. Y, bueno, tratar
This is a 6, by the way, not some other thing.
con todos los consejos que te hemos dado.
Then all we care about is the fact that x divides 6, or 6 divides x, which means x is divisible by 6.
Igual toda la suerte del mundo para ti, que tengas un buen domingo. Y bueno, si es que se puede hacer más viajes, pues a completar más viajes.
And what this means is essentially the only thing we care about once again is the previous element. What was the last problem we did? Wait, was that the time one? No, it was that? Okay. So basically the only thing we care about is the last element. So let's make this the last element. And then this will go out to dp of I plus 1, and then x, where last, or x is divisible by last, or last divides x.
¿No se está saliendo o qué? Y así yo te recomiendo de que te pongas la meta mínima. Te pongas la meta mínima, salgas a trabajar y el lunes te pongas una meta más grande. Si es que tienes una meta por selección, ojo, ya si es que tienes una meta normal, la de 800 soles por 132 viajes,
yeah.
Bueno, a trabajar nomás.
So like, nice. What would happen here? Did it just remove my message? Okay, interesting. I guess YouTube is doing stuff to my own chat. But basically it just says that we want to push this value out to all multiples. So, like, what's the deal? Isn't this like a high complexity? It would be, but the trick here is that it turns out to not be, because how many multiples do we have of I? Of 1, we have n. Of 2, we have a number on the order of n minus 2. Of 3, we have a number on the order of n minus 3. And in general, we have a number on the order of n over I. And the total complexity for a single value of that is this. The sum from I equals 1 to n of n over I. This is the harmonic series. It's like provably O of n log n. I'm not going to describe it here. But actually I did write a blog on this. Let's just find that right now. Because why not? And then I'll link that. And we'll just leave it as is. But essentially this sum is going to be O of n log n. So the total thing is going to be O of, what would it be? K, good sequences of length K. So K times n, which is the maximum value, n log n. And that's basically it. So let's just do that and finish this off. Maybe there's some formula or something, but who knows? I don't. So this goes up to K, and this goes up to N. So dp m plus 1, K plus 1. And we say it like, we have one way to make 0 and 0. Memset will just fill it with a value. But be careful with memset, you should probably only use it for 0 and -1, so I heard, because of the way it works. Like it's not what you expect. And the way this works is you just kind of like push this out. How would this be a base case actually?
Decorado de Diego Perú. Y se llevó su televisor.
Maybe it'll be something like this. We instead say this starts at 1. And then we'll put a virtual 1 at the beginning of a sequence, meaning that like all of these values are going to be at most n, but they also divide 1, so that kind of works. J equals 0, j is less than... Wait, this should be k, and this should actually be swapped. B equals j, b is less than or equal to n, b plus equals j. This is the multiple of j. We do mod. It's the first time we're actually doing mod. Nice. dpi j equals, no, I plus 1. The next value at v is that. And we have to do the mod and stuff. Yeah, but memset is weird. Like as you said, it does by character, which means if you try and set it to like 1, it's not going to be 1. Like it's going to set every 8 bits to that, which means in a 32-bit integer, you're going to get something like that, which is clearly not 1. But with with 0, it's just setting it all to zeros, and with -1, it's represented like this, which is universally -1. So it only works as you expect for those, as far as I know. But I'm not an expert on memset. You can probably read documentation if you want. Anyway, and the answer is the sum of all possible like previous values, because it doesn't matter what it is. Ants equals ants plus dpki mod mod. Okay. What? I have to read it. Nice. 5.
Ricardo, tú tienes lo que nuestro
39.
Instagram, que es Diego.
2. We do mod. Everything's good.
YEGO.PE. Ahí me puedes enviar las imágenes, por favor, y más o menos indicar qué es lo que... O si es que está desactivado.
Yeah, this stream will be archived on my YouTube. After, I think YouTube may take a while to process it, but it'll be up eventually.
Hace el reporte de servicio de asistencia indicando que la app está fallando porque has desactivado la opción de inicio automáticamente y aún se sigue iniciando automáticamente.
Okay, and that's basically the idea. We do first the position and then the element, and then we push it out to all multiples, and it just works because of the way the harmonic series works. Alright, well, that's all I have.
Lo reportas como falla de la...
Okay, I think in terms of the stream, that's it. Colin Galen signing out. Or signing off. Yeah. Or Kalen Galen, whatever you want to call me. Alright, this was fun. I guess we can continue this later. Maybe like more of the mashup or more of the anything or the implications of this message, which you will all find out later. Okay.
descansa.
De
Solo
verdad
me
que he descansado bien el
Yeah, alright, goodbye.
sábado. Siento que he dormido muy bien.
¿Te gusta la música, Ricardo?
Hoy descansas, hoy domingo descansas.
Hey, what's up, guys? Welcome to a new stream.
¿Te gusta
Welcome
la
to a new
música,
week.
Ricardo?
And today we are gonna do the AWS backend for the React Native application that we have started previous week. And we have started a TikTok clone. So if you didn't see that video, I would highly recommend go check that out. Or if you're interested only in the AWS backend, that's perfectly fine. You can find the source code in the link in the GitHub repository. So what we are gonna do today, let's quickly have a look. Not here, yeah. So we're gonna implement first of all authentication, because that's an important part of almost any application that you're gonna develop using React Native. So we're gonna set up the AWS Amplify with authentication that will give us pre-made screens for signing in, signing up, forget password, and and much more. And you'll see how easy it is. Like it's incredibly easy. I think it's like 3 or 4 lines of code, and at the end we have all these screens ready for us. After that, we of course need to save our data somewhere, and for that we're gonna create a GraphQL API. We're gonna get into more details about like the ins and outs and what is the GraphQL API. Again, we're gonna set it up with AWS Amplify, and the API will save all the data to DynamoDB. But that's also a lot of things are happening automatically. So at the end of the day, you don't even work with DynamoDB directly. You just set up everything. You just write like how will your models look, and AWS will take care for you about everything else. So that's the awesome part. And lastly, we need to save all these videos, all these files somewhere in the cloud. And for that, we're gonna use AWS S3, the storage solution from Amazon Web Services. And again, you'll see that it's not very complicated to set it up and record a video and then upload it there. So yeah, hello everyone. Where are you coming from today? Where are you watching the stream? Thank you very much for joining, and thank you for all the support you guys are showing lately. Yeah, let's wait a little bit for people to join, and then we can start to work. So guys, yeah, what other important things I have to tell? So hi Alexandra from Moldova. Hi Gabriel. Hi Vivek. Hello everyone. So guys, yeah, if you're new here, thank you very much for watching. On this channel we are doing this kind of clones in React Native, and also we are using AWS for the backend. And I'm doing this because I really think that learning with project-based learning is the best way to learn any new technologies, because yeah, a lot of people I know, a lot of my friends are struggling with in like a tutorial life cycle, like where they watch tutorial after tutorial, but they never start actually implementing something. And that's why I decided to start doing these live streams, because that's how I learned all the technologies that I know, and that helped me get an internship at Amazon. So yeah, just by doing things, just by messing around, by having problems and then trying to solve them by yourself, building an actual product that you can see and you can be excited about, yeah, it will make your life easier and the process of learning a lot more fun, instead of watching just some random to do apps or I don't know, Fury. So yeah, Yeah, if you're interested, please join our Discord channel. The link is down below. We have a great community where people are sharing their progress. If they have problems, yeah, the community is pretty helpful and everyone is helping each other. And from time to time, I also try to help everyone who is having problems. And yeah, if you can also contact me down below in the comments if you have any problems, and I'll try to help. Hello from India. Hello. Please teach us how we can add filter library as TikTok. Filters, you mean like video filters and like photo filters, things like that? If you're speaking about that, we're not gonna do that today. I'm not planning to do that today because we have a lot of things, as you saw, planned for today. But maybe in future, if a lot of people are interested, maybe we can implement filters as well. Hello, hello. So guys, yeah, let's get started. And yeah, as I said, we're gonna implement authentication, we're gonna implement GraphQL API and the storage. But first of all, we are gonna start with a GraphQL API. And before getting into that, like what is GraphQL API? GraphQL API is an alternative to REST APIs, and it's a syntax to define how the data from a backend will be queried. And usually the advantages of GraphQL API is the client is the one who decides what data he needs, and not vice versa. Like for example, if you are asking data about posts, but you are interested only in the ID of a post and I don't know, the image, without any like comments, without any, I don't know, users and stuff like that, you can do that with GraphQL by specifying like, okay, I need the post with ID and with an image, and that's it. In REST API, it's a bit different. You say like, I need this post, and they will throw at you everything that they know about that post that they have in the database. And also GraphQL makes it easy to aggregate different source of data and to aggregate different types of data. For example, with one query, you can receive a post with all the comments, and for each comment, you can receive information about the author of that comment. So it very easily for the client aggregates all the data from different sources, from different database tables, from different different APIs. So yeah, to better illustrate that, here I will show you what's the difference between a GraphQL API and a REST API. Here on the left, we have a REST API, and let's imagine a usual situation where in any like application with posts. For example, there is a list of posts, which is the feed, and each post has comments, and each comment is submitted by a user, and that is an author. So to render, for example, the Instagram or TikTok feed, where we render the post, we render three most common top comments and their users, like image and username. We would have, first of all, to create a GET request, to send a GET request to the server to get all the posts. And for example, we receive back 3 posts. Then for each of those 3 posts, we need to send one request for the comments. And that's like 3 other requests here for each of the posts. And then when we receive data about the comments, for each comment, we would have to query all the authors. So that's like more than 10 requests to the server for a situation where you have like 3 posts with each of them like 3 comments. On the other hand, having a GraphQL API, you can receive all this data just by doing one request, and you will specify like, okay, I have a post with top 3 comments with their authors. And then GraphQL will aggregate all this data on its end and will return it to us in one request. And that's much more optimal and more performant. And GraphQL works based on a schema. So a schema is defined by, in today's video, we will define the schema, and we will define how each object will look like, and how we will be able to query them, how we will be able to create them. So there are custom types that we create. For example, a type offer, and the type offer has an ID, a first name, a last name, and a list of posts. This is an array. Type post as well has ID, title, offer, votes. And also GraphQL schema contains query, and this is all the operations where we need to receive information from the API. And this is very similar to a GET request in a REST API. It's like getting the posts, getting the users, getting everything, anything you want. And there is one more which I don't have here, and that is a mutation. And a mutation is similar, is an operation similar to post request in a REST API. Basically, when we want to create something in the database, then we will run a mutation. For example, create post, create user, add comment, delete, update, and so on. So yeah, this is a very important part, because on our end today we're gonna write only this schema, and based on this schema AWS Amplify knows how to create all the resources, everything like database, and for each type, for example, for an offer, for a post, it will create a separate table, and so on. So a lot of magic is happening behind the scenes, but this schema definition is something that we will need to know. And yeah, that's a very short introduction into GraphQL. If you want to know more, definitely check out more resources. There is a lot of resources that you can find on Google, Medium, and YouTube. So yeah, without further ado, let's jump into initializing our Amplify, because that's what we need to do before adding the API. So I'm not sure, I think I'm missing, no, I don't miss, it's here. So first of all, let's set up the AWS Amplify project, and you can find that by accessing the, you can find more information how to install AWS Amplify on this link. It's docs.amplify.aws, and there you'll press on start, and then you'll choose React Native. So here is the first tutorial. Before starting, you would need to have Node.js installed on your system, and for this chapter I'm gonna go quickly through it, but I expect you to do it yourself, and I expect you to have this installed on your system before getting in to the next step, because that would take us some time if we would do it live stream, and I have them already installed. So you would need Node.js, npm, git. Yeah, initialize a new React Native application. We already have one. Then you would need to sign up for an AWS account. So to create one, you can access this link. An AWS account can be created for free. However, you need to attach your credit card. Most of the services that we are gonna use in this in the tutorial, and that you are gonna use while you're learning, most of them have free tier. Even here they explain, and the free tier means that, okay, you have like a limited amount of resources that are given to you for free, for you to learn and to test them out. But don't forget to delete those resources when you're done, to be safe. For example, we already created around 4 or 5 projects, and I'm still paying 0 to AWS because I'm under the free tier. On the other hand, at my startup, we have around 15,000 users, and I'm paying less than $70 per month. And our application is heavily based on videos, so it's pretty affordable, I would say. So yeah, then we would need to install globally the Amplify CLI. There is a great video that you can check if you want to visually to follow the tutorial, after which you need to configure the Amplify, and it will walk you through some creating some users, some policies, which will give you access key and a secret access key. You add it into your system, and then you are done setting up Amplify. So I expect you to follow this yourself. It shouldn't be with any errors. It's pretty easy, and then we can follow together the next step. So let's set up our full stack project. We already initialized the project. Now let's run Amplify init. Let's go to our project, Amplify init, to initialize the project. And what's cool about Amplify that you don't have to supply any arguments, but instead it asks you everything with questions, and you just type like all the options. So first of all, enter a name. I will leave it as it was, like TikTok. Environment development. Here, if you're using Visual Studio Code, choose Visual Studio Code. I don't have my WebStorm there. Our application is a JavaScript application and React Native from here. Then yeah, source path is the root folder, build command, yeah, everything we leave as default. And now it will take a couple of minutes. Yeah, we just need to say yes, do you want to use AWS profile? And here, if you left the profile during setting up Amplify as default, you will select default. However, I created it with a different name. So yeah, right now we will probably wait a couple of minutes until it sets up. So I have my coffee here. I already talked for 20 minutes. My voice is cracking. Recently, yeah, let's see what people are saying.
Igual no te olvides de que al momento en que te llamen, igual te van a pasar un link para que coloques.
What is the difference between GraphQL and REST API? Yeah, I think I introduced that in the slides, and hopefully it answered your question. Hello from Brazil. Hello. Can GraphQL handle the relation? What do you mean relation? If you are speaking about the relationships between models and types, for example, a relationship between a user and a post, yeah, GraphQL is very good at that. And yeah, once you set up this, like, it works like a charm, and everywhere where you have a post, for example, you will be able to access a user, and while you have a user, you'll be able to access all its posts. So with just a little setup, it works very nicely. Hello from Lithuania. Thanks for videos and your best, Vadim. Thank you very much. Yeah, I have a very close friend in Lithuania. Yeah. So as we see, Amplify have set up. It created for us a couple of files, for example, Amplify.json, the Amplify folder. Like, we'll not get into a lot of details right now. However, what we need to do is to run Amplify push, and Amplify push will take this, not push, but yeah, push, right? Or should we first of all add something? Yeah, before pushing, because we didn't add any services, we will first add some services and then push. Yeah, the next step would be to install all the libraries that we need, and we can copy them from here. And yeah, if you're using npm, stick with npm and use npm. I'm using yarn. That's just my personal preference. Nothing is better or worse.
Liso Django.
Yeah, amplifying it. Then we add we install all the dependencies like AWS Amplify React Native, and so on. And then with 3 lines of code, like we configure the Amplify in our application. So the dependencies have been installed, the npm packages, and the next step is only if you're working on macOS and you have set up the project to work with for iOS. And after installing the dependencies, we need to install the pods. And yeah, if you're running on macOS, run npx pod install iOS. This will make sure to install all the native pods of all the libraries that we currently added. Yeah, it installed. And the last step is to add the 3 lines of code, like importing Amplify, importing the config, and setting up the configuration for Amplify in our app.js. So let's go here. I think app.js was for Expo and index.js is for React Native. So here in index, yeah, we can import Amplify, set it up, add some semicolons, save, and then let's try to do yarn iOS to run the application on iOS and to see if everything is still working and running.
Sí, me dice que se está traduciendo en inglés, me dice Melissa. ¿Cómo?
Yeah, it